So in today's class, we'll discuss about Docker and we'll see how what is Docker and what is the usage of Docker, right? What benefit we'll get using Docker and to make containerizations and all. So we are going to learn a new technique or new form like new platform and new tools Docker to create the containerizations. So like virtualizations, right? We have heard about the virtualizations, VM, virtual machines. Similarly, we are going to work on the containerization. So let's understand what is containerizations and what is the usage of that. Okay, so before moving to that Docker, I hope you guys would have done some practice on the Jenkins and all, right? So once we finish the Docker, we'll integrate Docker with Jenkins and see how we can trigger the Docker directly from the Jenkins. Okay, so let's start. First of all, let's understand what is Docker. Okay, let me make it slide slow. So what is the Docker? It says simple word. Docker is a platform used to containerize your software. Used to containerize your software using which you can easily build your application, package them with the dependencies required for your application into the container. And further, these containers are easily shipped to run on other machines. So Docker is a platform used to containerize your software using which you can easily build your applications. Like, so containerize your software means whatever the softwares. So whenever you are building an applications, right? Whenever you are designing any applications or writing any product, so what happens? You need some sort of softwares, right? Some binaries, some libraries, and with the combinations of those, you need to put together and make the applications to run, right? Either whenever you are going to run the applications, if you are going to run in the virtual machine, suppose you have a Java applications you have built, and that Java applications you need to deploy into one of the virtual machine. I'm not talking about now containerizations. I'm talking about the one virtual machine. So in that virtual machine, suppose the Java applications, whatever things is required for that applications to run, the first thing is Java to be installed first on the VM, and then that particular libraries or the binaries should be deployed, and some sort of configuration should be there, and then you have to deploy the applications to run, right? So same thing in containerizations. What we are going to do, you are going to pack together everything in one place and make the container to run, make the applications to run in the containerizations. We'll just discuss the benefit of using containerizations, then virtualization. Okay, we'll see in next slide. So Docker is simplifying the DevOps methodology by allowing developers to create templates called image. So create templates called image using which you can create these lightweight virtual machines called as containers. So the Docker is simplifying the DevOps methodology. Actually, whatever the tools we are going to learn, in DevOps, Docker and Kubernetes actually simplifying the meaning of DevOps. Okay, we'll just learn how it helps us. Okay, because if you see, we had different kind of methodologies, right? Before we have waterfall methodology, then we got agile methodology, right? In agile methodology, what happens? We used to get some right. We used to get some piece of code, right? We have to make separate iterations, modules, and then we work on that, right? And then deliver. Similarly, in this DevOps methodology, DevOps, there is no methodology. It's not actually a methodology. It follows agile methodology, right? DevOps follows agile methodology, right? So in that, what happens? It actually simplifying the DevOps methodology. Docker is simplifying. Now, when we are going to use the container, we need to use one template. That template is called the image. Okay, we'll see how we can create our own image and default built-in image, and we can use the user defined image, like how we can create our own image also. So Docker is making these things easier for software industry, giving them the capability to automate the infrastructure isolate the applications, maintaining consistency, and improving the resource utilization. So Docker is making things easier for software industries, giving them the capability to automate the infrastructure, isolate the applications. So the isolating the applications is the most important things which we are going to achieve using Docker. And maintaining the consistency and improving the resource utilization. These three things we are going to see, and that is what the benefit will get in containerizations compared to virtualizations. Okay, let's see. So we understand what is Docker. It is a platform to use to containerize your software, containerize your application. Then what is virtualizations? Virtualization refers to importing a guest operating system on your host operating system, allowing developers to run multiple operating systems on different VMs, while all of them run on the same host, thereby eliminating the need to provide extra hardware resources. So, if you have a laptop, right? You have the laptop, you have the hardware machines, right? And you have the required software like resources. So when we talk about the hardware resources will be your hard drive, your keyboard, your laptop, right? Screen and everything is the hardware. The softwares and whatever the softwares and the hardware resources like the memory, the storage, and all these details, right? The memory, the card memory, whatever we have, suppose we have 8 GB of laptop, we have 1 terabyte of storage, right? Those 1 terabyte of storage and those 8 GB of RAM, 8 GB of memory, those will be used by the in virtualization. What happened? Your laptop, and you want to create, suppose, 4 virtual machines, right? So what you have to do in the 4 virtual machines, whatever you create, and you have to share few resources to them, right? Suppose 4 virtual machines, 8 GB of RAM, the total laptop is having 8 GB of RAM, and you are going to share 2 GB to one virtual machine, 2 GB to another, 2 GB to another, and 4 equal if shared, right? So in that case, what happens in tomorrow, suppose you need another virtual machines to be created, then you will not have sufficient memory to be there to allocate, right? Okay, we'll discuss the problem and all in the next slides. So while these virtual machines were introduced, they helped the industry in many ways, enabling multiple operating systems on the same machine. So on the same machines, as I told, we can have, suppose in this laptop, suppose I want to create 4 virtual machines. I can create 4 virtual machines, and each virtual machines have different operating systems. One I can keep as Ubuntu, one I can keep CentOS, and one I can keep Windows, right? Those I can create virtual machines, different virtual machines I can create. So it was cheaper than the previous methods due to less compact infrastructure setup. Obviously, it will be cheaper, right? In 4 virtual machines we can create, and we can just deploy 4 applications into that. Instead of purchasing 4 laptops, we can create 4 virtual machines. In one laptop, we'll have the 4 virtual machines. 4 virtual machines will have the 4 applications, right? So obviously, it will be cheaper. If there is any failure state, it was easy to recover and do its maintenance. Faster provisioning of applications and resources required for the task. Faster provisioning, because it will be a few commands you have to just execute to create and set up the machines and do the rest of the things. And deploy, it will be easy. An increase in IT productivity, efficiency, and responsiveness. So what? The virtualizations. In case of virtualizations, these are the things, benefits we used to get it. But in containerizations, what is happening? What is the containerization? Containerizations is a technique where the virtualizations is being brought containerizations to an operating system level. So here what was happening? It was happening. Virtual refers to importing guest operating system on your host operating system, allowing developers to run multiple operating systems. That's one. And it actually provides hardware resources, eliminating to the hardware resources. But in this case, what is happening? The containerizations is a technique where the virtualization is being brought containerizations. Whatever the virtualizations we used, that we used to create containerizations on an operating system level. On an operating system level, right? We'll see how in the operating system level it helps us. In containerizations, we virtualize the operating system resources. It is more efficient as there is no guest operating system consuming the host resources. So in case of virtualizations, we had the guest operating system, but here we'll not have the guest operating system. Whatever the host operating systems we have, the containerizations will work on your laptop directly. As many as container you can create. No need of any virtual machines. Okay. So as containers utilize only the host operating system and share relevant libraries and resources only when it is required. So the required binaries and libraries of containers run on the host kernel, leading to the faster processing and the execution. So containerizations or containers is a lightweight virtualization technology acting as an alternative to hypervisor virtualizations. So what is this hypervisor virtualizations? So actually hypervisor is a technique or is a the VMware, the company name, right? The VMware who created the virtual machines. So they had the software or the program or machines which called hypervisor. Using this hypervisor, actually we can achieve the virtualizations. Okay. So bundle any application in a container and run them without thinking of any dependencies, libraries, and binaries. So whenever we talk about the container, we'll never worry about any dependencies, because before creating the container itself, whatever dependencies required for an applications to run, everything will be bundled together in the image, and that image we are going to use to create the container. So we are not going to miss any libraries or binaries in production. So in case of virtualizations, what was happening, whenever you go for a production deployment, you might forget to deploy the required libraries, binaries, right? The same thing when you would have done testing in the test platform, right? Your application should be running fine. But when you go to the production environment, you might forget, suppose due to some human error, you forget to copy one library's binary. What will happen? The applications will fail to respond. Then what will happen? Then production issues will come, right? But in case of containerizations, what happened? Whatever the things we have already bundled and tested in the test platform, the same thing, after the testing is done, you just put into the production environment. And that will run because the container will have already the required libraries and binaries which already been tested in the test environment. Right? That image can be transferred to the, that's why in the very beginning, if the, here it says build, share and run anywhere. Build, share and run anywhere. That means in Docker, in case of Docker, we can build our applications, our product, right? In any platform, and share it to anywhere, and then we can run it without worrying about the dependencies. Right? So think about a real-time scenario, right? Whenever you are like you would have seen the containers, right? In the C, you would have the containers, right? There would be multiple containers. A C would be containing multiple containers, right? So in one of the containers, they would have, suppose if we are exporting something or importing something from outside, what do we need? Maybe we are suppose importing some kind of medicines, right? Or some kind of glass items or a Chinese product or something we are just importing. So what they will do, they will not keep everything in one container, right? They cannot keep medicines, glass items, or iron items, or something, wood items combined together, and they cannot put in a container, because if they put in one container, what will happen? When they reach to India or to the shore, everything would have broken or damaged, right? So to isolate those products, we can create separate containers. For glass items, one container with sealed pack with required supports there, not to break. And for medicines, we'll have separate container. For wood item, for iron items, we'll have separate containers. Now what happens? We isolated everything, right? And those things can be easily saved from a far distance to the from source to destinations without any worrying about damages. So that is here in the software line. In the DevOps, container is going to help exactly the same way. Okay, let's see the next. What is the advantages of this? Containers are small and lighter in weight because they share the same OS kernel. Why they use the same OS kernel? Because they are using the same hardware of the host operating system, because they are using the host operating systems. They are not using the guest operating system. We'll talk about what is guest and what is host. Don't worry. And the next slide. So it does not take much time to boot off. In a fractions of seconds, it will deploy everything and make your applications ready to use within fractions of seconds. High performance with lower resource utilization. That is the advantages of Docker. Sorry, not Docker, containers. So with the help of Docker, we are going to work with containers. Okay. So in case of containerization, all the containers are sharing a similar host operating system. Multiple containers get created for every type of applications, making them faster, that too without wasting resources, unlike virtualizations where kernel for every OS was required. So which utilizes a lot of resources from the host operating system, which utilizes a lot of resources from the host operating system. Okay, so these are the advantages. We'll see in details, complete hands-on. That time you'll understand more. Now I'm just telling you some theoretical to understand what is the Docker, what is the containers, what benefits we are going to get it. Then we are going to now directly work on the lab, right? See, here is the diagram. If you see this particular VM part, the virtual machines part, you'll understand here clearly. The virtual machine, we have the host operating system. We have the host operating system, right? And this host operating system, we have the using the hypervisor, we created suppose 3 virtual machines. We created suppose 3. So here in this, suppose we have 3 virtual machines, and these 3 virtual machines, we have the host operating system. Suppose in my case, suppose in my laptop, right? My laptop has suppose Mac operating system, and that I have created 3 virtual machines. And in these 3 virtual machines, I have to install different operating systems. 3 operating systems I need to be installed in this virtual machine. Suppose I have this VM1, VM2, and VM3. In these 3, we are going to install 3 different operating systems, and we have to pay for this, right? Operating system, whenever we are going to operating in the organizations, right? You are going to use the enterprise versions of the operating system, and you have to pay for that. For each machines, if you're going to install, you have to pay for that. And then each machines, you have to install the required binaries and libraries, then you have to deploy your applications. Similarly, things in 3 virtual machines you have to do, right? So what happens here, it is heavy weighted because of this guest operating systems. We have the host operating system on top of our guest operating systems, and then we have all these things. So it is costly and time effective and takes more time to work. But in case of containers, if you understand here, we have a host operating system, and then we have to install the Docker engine. We have to install the container engine or Docker engine there. Docker you have to install, that's all. So once you create the Docker, you don't have necessarily required the guest operating system. Here, we don't need in containers in Docker. In our Docker case or container case, we don't need guest operating systems to be there. So we can simply create the containers with the required libraries and binaries and bundle together with the applications deployed and run it. So when we run it, what will happen? It will use the resources of the host operating system. It will use the resources of the host operating system. So the kernel of the host operating system, the required resources like the memory, the storage, everything will be used in the host operating system. But here, in this case, these virtual machines, these applications, and all these things, they will use the kernel of this caged operating system. Okay, and we have to assign some resources to these particular machines in order to run. But here, these resources, everything will be there with host operating systems, and they use as per their requirements.
So Ranjit, like on the performance level, like whether the containers or individual VMs will have more performance, or how it will be, Ranjit?
Performance wise, containers will be has more performance because of its lightweight in nature. Why lightweight? Because it does not have the extra operating systems there, right? It does not require the extra kernel. It works on the same operating system, same kernel here, right? The performance wise, it will be faster. Containers are the faster, but it is virtual machines are a little lower.
Okay. Okay.
Let's see, and you'll understand more. Virtualizations and what is the difference? Virtualizes the hardware resources in case of virtualization, but in case of containerization, it virtualizes only the operating system resources, and it requires the complete operating system installations for every VM. It requires complete operating system, but in case of containerization, it installs container only over a host operating system, as we saw in this diagram, right? Now, a kernel is installed again for every virtualized OS. So obviously, for every time you install the operating systems, you need a kernel to be there, right? Each operating system has a kernel. Now, only the underlying host operating system's kernel is used. This is heavyweight virtualized, and this is lightweight. Limited performance, native performance, fully isolated, process level isolated. We are getting isolations in both cases. In case of virtualizations, we get isolations. Also, in case of containerizations, we get isolations. But here is fully isolated because we have 3 virtual machines and all these things. So we are getting these things. And then in case of this process level isolated, we'll see how it is working. Right. Next, let's see. Okay. So here, if you see the comparison between the resources, how the resources are being used, by different in case of virtual machines and in case of Docker. So if you see here, the comparison of the resource utilizations, I was talking about how it is helping in case of resource utilizations, right? So if you see this particular diagram here, in case of virtualization machines, we have suppose total memory of 16 GB, and we have created 3 virtual machines as per our previous diagram. And when we create virtual machines, that time itself we have to allocate memory. Suppose we have 16 GB of RAM, right? 16 GB of memory. And in case of 16 GB memory, I created 3 virtual machines. Suppose assigned 6 GB, 4 GB, 6 GB each. That means we don't have anything left in the host. Everything is assigned to these particular virtual machines. And if I need to create another virtual machines, I will not have any memory left to assign, to allocate. So what will happen? We have to either increase the memory, the host operating system memory, or we don't need anything to be there, or we have to get another machines to create. But here, if you see here, in case of virtualizations, what happens? We have allocated 6 GB to VM1 and 4 GB is used, 2 GB is free. That means this 2 GB is wasted, right? No one else will use this one. Similarly, here 1 GB wasted, and here suppose 4 GB wasted. You can see here memory used total 9 GB and memory wasted total 7 GB. So 7 GB of memory is blocked and cannot be allotted or allocated to a new virtual machines. As we already have assigned these things, we cannot assign any left over here in the virtual machine level to another virtual machines, right? So here what will happen? It's a total failure of assigning or allotting the resources here. If you need to do that one, then you have to reallocate memory again to lower it and then assign to another machines. It will take time and it's actually cost effective. In case of Docker, what happens? Same case, suppose 16 GB. and allotted memory is 4 GB. Allotted memory is suppose 30 GB. Okay, it is wrongly written. 35 GB. Suppose some 6 GB or 6 GB. So what will happen? Anything. If you allotted 10 GB also fine, 35 GB also fine. But what will it will use? It will use as for its requirement. Now, suppose this particular app, particular container is using 4 GB, and this particular container 3 GB and 2 GB. So total 9 GB is used, and the 7 GB will be free. So we can create another container, and that container can use. Let's give you an real-time example here. If you have a water barrel at your home, right? If you have a water barrel at your home, and you have few people there sitting there, and what if either you can get one 1 liter bottle, get some water, 1 liter water, and hand over to one person to drink. So what will happen? Whatever water he will drink, whatever he feels thirsty, right? And the rest will be left over in the bottle, right? And another case, what you can do, you get one glass, get some water from the barrel, and give to that another person. So what will happen? He'll drink whatever also thirsty, but he'll drink all the glasses, right? There you know the resources is used whatever is required, right? Here in this case, what happened? Only a glass of water he drank, but the rest of the water is still there in the barrel. But in case of bottle, what happened? We got the 1 liter, but he drank only 200 or 300 ml, but still 700 ml still there in the bottle. And suppose he just used directly tossed in mouth, and nobody can else drink that bottle, right? So he has to only use it. So that is the case in case of virtualizations machines and Docker, right? So here is that is the virtualizations and
Ranjit, like here also we have allocated, right? So if you see like app 1, 2, and 3, so you have allocated memory, right? For the first one, you have allocated 4 GB.
yeah.
Something you have allocated, right?
So here also we allocated, but the thing is here whatever memory you even allocated, the memory whatever it used, that will be used, and the rest of the things will be free. Why? Because why it is used, how much that the amount it is required, and the rest it left over. Why? We already have discussed few slides before, right? Why?
Because we already do the dependencies, libraries, and so
No, because the containers, because the Docker the containerizations, in case of containerization, what happens? It uses the host operating system. It uses the host operating system's resources. That means in host operating systems, you have suppose 16 GB memory, and it uses only 4 GB memory, and the rest of the things will be there in the host operating systems. But here, in case of virtualizations, we are allotting directly to the different machines. If anything left, and that will be part of this VM1 and not to the host operating system. It will be under the guest operating system. But here, as we are using the base host operating system, so my laptop being used, suppose, and my laptop will have the same memory. Whatever the memory is being used by the container applications one, the rest of the things will be free. Okay?
Okay, Ranjit.
Okay. Now, Docker architecture. So now you understood the basics of containerizations and virtualizations, why we need containerization. Why I'm explaining more, because that is, if you don't understand why you're going for containerizations, if you ask some questions, then you may not answer it, right? What is the benefit of using the containerizations? These are the benefits of things, whatever I just discussed, right? Next, let's understand about the Docker architecture. Docker uses a client-server architecture. Okay, Docker uses a client-server architecture. It will be very easy, very simplified, very simple to learn. Okay, so the Docker client consists of Docker build, pull, and run. build, pull, and run. The client talks to the Docker daemon, which further helps in building, running, and distributing the Docker containers. So Docker uses a client-server architecture. It has only client and server, client and daemon, CLI, command line interface, and the daemon. So you have to just put the command and you'll get a response back from the server. That's all. The Docker client consists of Docker build, pull, and run. These are the commands we are going to execute from the client side. So the client talks to the Docker daemon, which is nothing but the server side, which further helps in building, running, and distributing the Docker containers. Docker client and daemon can be operated on the same system. Otherwise, you can connect to the Docker client to the remote Docker daemon. These both communicates with each other using the REST API or Unix socket. So we can install both Docker client and server in the same operating, same machine, or else you can separate them also. You can keep client in one place, you can keep server in one place, and you can connect to that through API, right? So the basic architecture is client, host, and registry. Docker consists of three parts. Okay, client, host is the server, and Docker registry, which is dockerhub.com. So registry is nothing but the storage area or the source code management kind of things. It's like where you can register or store your images. Where you can store your images. That is the Docker Hub registry. Okay. We'll see everything we'll learn in Docker. Don't worry. Okay. Docker registry. Now, this is the diagram. Okay. This is the client. See, client, host, and registry. So in case of client, we are just using some few commands. Client is nothing but your CLI. What is the CLI? The command line interface or any GUI or any API you are going to, client side, you are going to execute the commands. So the Docker build, when you use the Docker build, it will just build the image and create that image and pull that image or run any container. Okay. So in the client side, when we execute these things, it will talk with the Docker daemon, which is on the server side, right? Then Docker daemon will build. If you are going to build, then Docker daemon will build an image. If you're going to run, then Docker daemon will create a container, right? Once a container and once the images is created, you can store this image in the registry. We can store the image in the registry and then we can pull the image from registry and create the container. This is very beautiful things, guys, and very easy to understand. When we do the real time, right? Just understand this image. Keep in mind, we'll just in the client side, we'll just execute it. Docker daemon will handle those requests, create images, and that images can be kept it in the registry. Also, if you want the Docker daemon to pull something from the registry, you can do that. Pull, it will go here, pull that image, come to the server, and there you create the container. It's very simple. Okay, let's understand further. What is Docker client? It is a primary way for many Docker users to interact with Docker. That is what I was telling, the CLI thing, right? Command line interface through which you will interact with the server, right? So uses command line utility or other tools which uses the Docker API in order to communicate with the Docker daemon. That is the client. The Docker client can communicate with more than one daemon. If you have the setups, if you have more than one daemons, like if you have more than one Docker servers there, then you can select to communicate with more daemons. In Docker host, we have Docker daemon, containers, and images. So let's understand the object on the Docker host, then we'll proceed towards the function of the Docker daemon. Okay. What is the Docker daemon? If you see here, in Docker host, we have Docker daemon, containers, and images. Docker daemon. Right? Docker daemon helps in listening requests for Docker API. Docker daemon helps in listening requests for Docker API. And it helps in managing the Docker objects. It helps managing the Docker objects such as images, containers, and volumes. There are lots of objects. We'll talk when we work on that. Then daemon issues to build an image based on the user's input, then save in the registry. So what daemon does, as we have seen, it does build, pull, and run. Build means when we build, it will create the image, that object, and it can store in the registry. When you do pull, then that image can be pulled, then can create run, then it will create the container. In case you don't want to create an image, then simply pull an image from the Docker Hub. It's the registry, okay, where you store all your images. It's a repository kind of thing, okay, storage where you store your. So if you don't want to build in any image, you can simply pull that image and create the container. Then in case you want to create a running instance of your Docker image, issue a run command which will create a Docker container. Also, Docker daemon can communicate with other daemons to manage the Docker services. What is the Docker registry? Simply, as I told, Docker registry is a repository for Docker images, which is used for creating the Docker containers, which is used to creating the Docker containers. So one can use local or private registry or use the Docker Hub, which is the most popular social example of Docker repository. So this Docker Hub is a Docker's native repository where you'll find all kind of images, built-in images, and your images. You can create private and public local repositories where you can store your images. I'll show you that everything in class. Okay. Okay. So we have these two Docker objects. One is the image. So what is the image? As I said, a Docker image is a type of recipe or a template which can be used for creating the Docker containers, which can be used for creating the Docker containers, including the steps for creating the necessary software. Okay, so the Docker image, as I said, is a template which can be used to creating the Docker containers, including the steps creating necessary software. So in that image, actually a bundle of the things whatever we need it. It's actually a template which contains the all instructions which a container need to run, which an applications need to run in a container. So what is the container? Container is a type of virtual machine which is created from the instructions found within the Docker image. So a type of virtual machine which is created from the instructions found within the Docker image. So a running instance of a Docker image which consists of an entire package required to run an application. So that is the container. Okay. Let's see more further about this. Okay. So we'll talk about the installations now. So that's all about the theoretical and fundamentals on the Docker. There's not much. Now let's go on and do some theoretical, some installations of the Docker. So how will do it? It will be very simple, guys. Okay, it will be very simple ways to do that. So let me just connect to the AWS side, and I'll just get to one server there, and there we'll just try to install software. Okay, just give me a second. I'm just going to try quickly turn on one EC2 instances, and there I'll show you how to install this Docker and the required softwares, right? Let's quickly do that. Okay, so the instances I just started, just hold on for a few seconds, let it run, then we'll start doing that. You can do practice also, guys. Okay, we can do practice this one. Okay, so by the time it gets running, okay, we have this server gets up. What we'll do, I'll show you that registry part. Okay, so what is that? The registry, Docker registry, you can use to store your images. Okay, store your images and you can get also inbuilt images which you can use in your project. Right? Let me just go through that one. So the URL for this is hub.docker.com. Okay, hub.docker.com. This is the registry. This is the web official registry of Docker. This is the official registry of Docker. So what I can say here, you can register yourself. It is free. Okay, it is free to use. You can click on the register and start working on that. You don't have to pay anything for that, and you can freely use it. Okay. Now what I'm going to, let me sign in. Ghost Docker Ranjit, continue, and the password. The password. Okay, so I have registered myself, and when I just log in, I can see Docker for Ranjit, which is my registry ID. Okay, I have registered myself, and you can see I have a few images which I have created and put it here. Okay, there are a few images which people have also downloaded. 33 times this one has downloaded, and this has 49 times this particular image has been downloaded by the people. Okay, now when you either you sign in or not, also what you can do, let me just log out first here, sign out. Even though you don't have sign out or have not registered also, you can simply search any images. Suppose I want, suppose the operating system, Ubuntu operating system's image. Okay, so what I can do, I can just simply search for here, Ubuntu. See, we have these Ubuntu images available. Remember, guys, this registry will have, this is a repository system where it contains all the image storage and details. Okay, now this Ubuntu image, we have this Ubuntu image, and you can see here we have this tag called Docker official image. This Docker official image, whenever you are actually using in your company, right, make sure that you always use Docker official images, not the image which is created by someone else. Okay, if you see here, we have all are the Docker official image, and it is verified publisher. Someone else has verified it. It's verified publisher, and it's just check. This is 1 billion plus downloaded. Ubuntu has been downloaded 1 billion plus times. Okay, if I just click on this particular one, and it gives us the command how to pull this particular Ubuntu image. Simple, very simple. Okay, and also it has all the tags and all. If I go all the details, what is Ubuntu, about this image, little image, you can get it all these details here. Okay, and also if you just go to different versions or tags, click on these tags, and you'll find the entire history of the tags, which tag you want to use. Right, it has a different versions of the tag, 22.4, Lunar, this number, kinetic, all these are the, it has multiple things, right? 50 or 100 pages of the tags are there. So whatever tag you need, you have to just copy. See here, Docker pull Ubuntu latest. This is the latest tag. If you want to use rolling tag, you can use Docker pull Ubuntu :rolling. I'll just explain and do in hands-on completely. Don't worry about that. Okay. And if you want to find anything else, any image, suppose if you want to find HTTPD, like the Apache web server, right? Select here. See, HTTPD official image. If you want to search for MySQL database, if you are going to use, search for MySQL, and you'll find MySQL official image. When we do the demo and the project, I'll show you all the images usage of all these images. Okay, don't worry about that. Anything, if you want to search it here, if you want to search your Jenkins, even you can find Jenkins image also here. You can find Jenkins image here. See, Jenkins image, official image Jenkins. Now, this is the things, right? And if I search for my image, suppose Docker for Ranjit, okay, slash, if I see, it gives me all the images whatever under this Docker for Ranjit register, right? I have registered with this name and I have these images available. So all in my community. See, these are the images of mine, which I have publicly shared. Got it? I have this MySQL also. Now, what you can do here. Now, once you register, your task for you is to first register today with Dockerfile. Okay. Now let's move on. We have this server is running now. Let's try to install Docker and do some hands-on. Okay. What I'll do, just get the public IP address here. Get the public IP address and as usual, log into the server. The way you log into the server, either you use PuTTY or directly terminal to use, log into the server. Search. Okay. Got it? So I just connected to the server. Now let's do here, try to install Docker. Try to install Docker. It will be very simple, guys. Only one command you have to use. Sudo, okay, yum install Docker -yes. That's all. Sudo yum install Docker. Okay. To know more about the installations part, you can just use Dockercom, right? Docker.io or Docker.com. You'll find this is the official Docker.com is the official page of Docker. Is the official page of Docker. You can find all the informations over here. You can find see build, share. That is what I have written, right? Build, share, run. It gives us, so what it says, Docker takes away repetitive mundane configuration tasks and is used throughout the development lifecycle for faster, easy, and portable application development. So what is build does is build get a head start on your coding by leveraging Docker images. We are going to build the Docker images, put together everything. You can just work on that, right? The packages and applications. Then share, you can share to anywhere. Leverage Docker trusted content, including Docker official images from the verified publishers, whatever I was just showing you in the things, right? We have Docker official images verified. So what happens? We started building our images and then we shared in the internet and get it and run it anywhere. It's very, very simple, right? In case of virtual machines, you cannot do this, right? You have to need that machines to install and create the VMs. But here in this case, create the image, share it anywhere, get it that image, and any machines you can create it. That's very simple, right? Now, if I go here, need to install, right? They have modified and upgraded to Docker Desktop. As I'm using the MacBook, by automatically finding the operating system and gives me to download the Apple Intel chip, this one, right? Download Docker Desktop for Apple. It gives me. But if you're using Windows or Linux, you can click any one of these, right? Suppose I'll go with Linux, click on the Linux one, and it'll give us the required installation steps here. Required installation steps. And this is nothing for your Docker Desktop. Okay, this is for Docker Desktop. Docker Desktop is actually one UI kind of tool where you have to just execute and you will not get that much fun there. Okay, so Docker Desktop is kind of, you can just install Docker Desktop in Linux machines, in MacBook, in Windows also. Okay, Docker Desktops. And remember, guys, Docker has some prerequisites, some requirement. You can go with this requirement to install Docker Desktop successfully for Linux host. So you should have 64-bit kernel, okay, and KVM virtualization support on. And we need this key UEME must be version 5.2 or newer. At least 4 GB of RAM is required, right? All this information is required in case of this one, right? And he has some few steps here to install on different kind of machines, right? Okay. But I would suggest you very one simple commands to do practice and hands-on. You can just use standalone Docker command sudo yum install docker. Yes. So I'm going to install on Amazon Linux. Then let's see. It's just installing all these softwares, right? This Docker is installing my machine. Just wait for a few seconds. It will be installed quickly. Yeah, it's done now. It's done. So what I can do here, let me just check whether the Docker is installed or not. If I just do Docker version, sorry, what it says, it gives Docker version, it gives us the client version, this much 20.0, and it gives the API version. Okay, so but it says cannot connect to the Docker daemon. Is the Docker daemon running? So let's see whether we just installed, but we have not started yet the Docker, right? What I can do here, let's check whether the Docker is running or not. System status Docker. There is spelling mistake status. So it is inactive or dead. It's not running, right? So now let's first start it, right? You have to make sure you are under sudo systemctl start systemctl start and docker. Okay, hit enter. Now if I check the status, see, it's now running. It's now running, right? So if I do here sudo, let's first make ourselves as root sudo su. Let's clear it. And if I do Docker version, see, it gives us complete version details of client, and it gives the server engine. This is the server engine and all the entire details it gives us. Okay, good. The things are installed now. And one more good things I'll just tell you to use for your help. What is that is whenever you need any kind of help, right? And if you forget any command to use that, simply use Docker help. Docker help. It will give you complete list of commands with the usage. So you can easily get it and work on it. See, it gives the complete usage of the Docker. The management command, the builder, right? The management command, the management commands, and we have this commands list of commands which are going to use with part of this management commands. So we have these management commands. Before we had only 5 or 6 commands out there, so 7 or 8 commands were there, but now they have increased multiple management commands they have created. Anyway, based on our requirement, we are going to use this. Most of the commands I'm going to show you. Okay, now this is a very simple things, right? Our installations is done now, and you can see here the management commands. I'm going to run first, work with this container management command. Container management. Suppose if you want to know how to use this container management command, how you can do? You can just use Docker container. The management command is container and use help. So it will give you the help of container command, container management command, right? See, so help and how to use is this one, manage containers, and these are the sub commands or commands you can use with the containers management command. Okay, now ls to list the container, kill to kill the container, logs to check the logs, rename, restart, stop, top, start, cp, attach, everything. I'll just show you most of these commands. Okay, now let's go ahead. Now everything we'll do the hands-on, right? Now what I'll do here, I'm going to show you today. So installations is done. Let's play around with the container. So I'll just use Docker container, okay, Docker container ls to check what are the if any containers available or not. See, okay, we don't have any containers available. Check whether we have any image available or not. So for that we can use the Docker image management command ls. Here we don't have any image available. So what is the image, guys? The image is the recipe or template and can be used to create the container, right? So it is a bundled or packaged binary file. Okay, it is actually image a binary file which contains everything which a container need to run. So before creating the container, we should have the image available. Before creating the container, remember, before creating the container, we should have the image available with us. Okay, now, and remember, Docker container is a, so we know that two major objects are the image and container in case of Docker, right? So image, remember this point, image is a build time object and container is a runtime object. So what is this build time object and runtime object? Build time object, during the build, after build, whatever is created, that will be the build time object. So when the object image is created and if you use running that image to create the container, that will be your runtime object, right? The container is the runtime object and image is a build time object. Now, we don't have anything available here. And suppose I want to create a container of Apache server. How will do that? Okay, how I'll do that? First thing, either you can directly use the run command, or what you can do, you can first pull out the image and then create container out of that. What I'll do here, I'll show you two examples with two different ways to do that. First, let me pull that image which I need to create a container. Suppose I want the Apache server, HTTPD server. Let's do that. For that, you have to use the command docker, okay, pull, docker pull, and give the image name. In my case, HTTPD. So here, I simply gave HTTPD, right? I simply gave HTTPD. If I don't specify any tag here, if I don't specify any tag here, what will happen? It will download the latest version of the HTTPD image. Let's see what happens using the default tag latest. See, remember that could be a question. If you don't specify any tag here, what will happen? It will download the latest version. But this is not what the requirement for your company or for your project you could be using a different version of image. Then you have to specify that particular. Suppose here I need some different version. Okay, to find out which version you need, go to the Docker Hub, right? hub.docker.com, and there what you have to do, you have to search for that image. Suppose in my case is HTTPD. Sorry, not here. Search here. HTTPD. Hit enter. And here, click on this particular HTTPD official image, right? Click on this and go to the tags. Go to the tags. And here we have different tags available. We have different tags available. See, different tags. Suppose I need this particular versions. Suppose I need 2.4. Okay, I need this 2.4 tag. What I have to do here, simply use colon 2.4. Hit enter. Okay, here when I use tool Docker pull this particular 2.4 tag, you can see here 2.4 pulling from the registry or library, and this is the digest. So now I have pulled two images. I have pulled two images, right? So if I do Docker image ls, Docker image ls, right? Hit enter. See, I have now two images downloaded from the registry, and it is these two images are now locally available in my machine. These two images now available locally in my machine, right? Now, with these two images, suppose I want to, now what happened? I just pulled two images. In one of the image, I just want to create a container. And to create a container, how will do that? Use the Docker management command name is container, and use run command, that is to run an image to create the container. So I'll just use run. Then you can use various options here. One of the options I can use -d, that is in detached mode, right? And one other option, suppose I use give a name. Another option is there, suppose IT, interactive, means that will be attached to the terminal. That will be attached to the terminal. Let's give it IT and use a name, -name. Suppose I'll give a name as web app. Okay. Then you have to pass. We have to publish it to use this one. Suppose 80:80, 80:80, and then what we need, we give a name and then publish, and then you have to provide the image name, which image you have to use to create the container. Suppose I'll use HTTPD. So guys, if I don't give anything, what will happen? If I just use HTTPD, what will happen? If I don't give any tag here, what will happen?
So it will use the available or latest one.
Not available one. It will use the latest.
Latest one. Okay.
It will use the latest one. So be attentive, guys. Okay, listen whatever I'm telling. So you have to use the latest one. Suppose I want to create the container from 2.4 tag. So you have to specify which image. What will happen? Now it will create. See, it's just created the container. Okay, what will happen here? If you see here, if I use docker-it, it will interactively attach to the terminal. I cannot execute any command, further commands here, right? So for that, what I can do, let's Control C. Either you can just open another terminal and there you can search it, but you can use, if I see, even though I just use this one and it created container, let's see whether we have container created or not. We have Docker, use container management command, ls. So we don't have anything. Now if I do ls-a, check all commands, it will give us one container. So this command will give us only the running container, active container. And this command will give us all container, active, dead, exited, everything. Now you can see here, as I pressed Control C here to come out from this, because it was attached to the terminal, I could not execute any commands. So I pressed Control C. When I pressed Control C, it terminated the container. It exited the container 2 seconds ago. Now this container is dead. Okay, and we have this one container available. Now, if I don't want to attach to this terminal, what I can just do, I can simply use, instead of -it, you can use -d, -d in detached mode. Okay, in the background, it will run in the background, right? And we have already again name given. Let's give a different name as web app 1. Let's hit enter. See, it's just created a container and gave us the container ID, too big ID, right? This is the container ID. And this container ID, if I just do Docker container ls, see, we have this container and it is up. It's still running. This container is now running, right? If I do container ls-a, it will give us both two containers. See, two containers, all containers. Exited, also running container. If I just give ls, it will give us only one container. Now you understood this container. Now you'll be thinking, how will access this container? This container is having our application. How I'll access this application, right? As I have this command I used to port forward. This is called port forwarding or publishing. What is this? Just try to understand, guys. When I executed this particular 8080, so what is this 80? Is a port, default port of this Apache server. If you install Apache server on your laptop, on your machine, then you make sure that HTTP port 80 is whitelisted or firewall. Then only you can able to access the HTTP server, right? Same thing here. I am using the container also. Whenever we create the container, also will have the port number 80 by default. And to access the container, we have to publish the port of container or forward the container port to the host port, to the machine port, to the laptop port. Then you can able to access that one from your laptop itself, right? From your internet itself, from your browser, right? That's why I have to forward it or you have to publish it -p 8080. The first one is your container port. This one is your container port and forwarding to host port. Container port is forwarded to host port. Okay. Now, if you want to give any different port name here, 82, then you have to use 82 in order to access the application, right? Let me do that. Okay. Now, how will access that one? So you need the particular IP address of this one. Get this IP address, and how will access the container? Go here, hit enter. See, it gives, it works. The container is running, right? So the container is running. Now, if I just want this container to stop, I'll do that. Use Docker container stop, right? Provide the container ID or the container name. Container name is web app 1, or if you don't remember, because this is quite difficult to remember the container ID, right? So better you can just give web app 1, or you can just copy this and paste it here, right? Hit enter. So I just stopped this container, right? Just wait for a few seconds. It will just get stopped. So the container is stopped. So if I go here and refresh this page, see, because our container is stopped now, we cannot turn. So here I deployed the applications, web applications with this container, right? Now, what will happen here? The container is stopped. Now, if you want to start this container, simply you just, instead of stop, use start. So it started the container. Now, if I go here and refresh, see, our application is running. This is one way. Okay, our containers are there. Now, let me just show you some ad hoc containers. Okay, other containers. Like if you want to use some containers, like create one BG box, okay, a small BG box, and you want to execute some commands. So what you can do, use Docker, okay, -g or Docker run, simply Docker run. Okay, give, if you don't give name, it's also fine. It will randomly give you a name. Docker run, just give BG box, okay, and give a command. Suppose command I'll give as date. Hit enter. So just try to understand this. I'll just tell you, right, what will happen here. See, guys, what it did, it just, first what it did, unable to find the image locally. Remember, guys, this is very what they can ask you, the life cycle of the Docker container, or they can ask you what is the flow of the Docker, how the Docker works. So you can say here, whenever you just execute the run command, Docker run command of particular image, the Docker, what will do, it will search that image locally. In our case, I'm searching this BG box, right? If you just search the BG box here, search the BG box here, we'll get the BG box, BGBox image also. So what is this BGBox image? Actually, it is a very tiny, small Linux utility. Okay, BGBox coming with someone between 1 to n disk size. BGBox combines tiny versions of many common Unix utilities. That's why when I executed this command, run docker run BGBox. So run means we are going to create a container out of this image. Then Docker will locally search daemon, Docker daemon, right? Will locally search for this BGBox, whether the BGBox is there or not in the laptop, in this server. If it is not there, it will download from the library, from the registry. Then first it pulled, right? It pulled from the registry and then it created the container. After creating the container, it executed this command. You can see here, it gives us the date, right? It gives us the date. What is the time? 3:53, right? If I execute again, it will create another container and it gives us the date. See, 3:55, 3:53 I had executed. Now if I just executed another command, suppose instead of date, I'll just execute, suppose uname or uname. See, it is a BGBox. This container is a Linux container. It gives the command. Whatever the command you pass, it will execute. Now, how many images would have been created now for BGBox? Three containers. It would have created 3 containers now, here, here, and here. Now, we have not given any name, right? Let's do check here. Docker container ls-a. Right? See, I have 1, 2, 3, 4, 5 containers. 2 for HTTPD and 3 for BGBox. And this BGBox has given a different name. See, gen_tu, objective German, reverent Shannon. These names, if you don't specify any name to your command, to your container, if you don't specify a name to your container, it will give randomly a name to that container. Okay, so here and immediately you can see all are exited. The nature of this container is as it is a very tiny small Unix utilities box, right? It just executed the command and then it will be exited. The container will not be live. But in case of this HTTPD, as it is running in the foreground, it is running the web applications, we need to access it, right? And the command, it is running in the foreground. See the commands which is getting executed, HTTPD foreground. It means it will keep the server to run all the time. Okay. Here I forcefully exited using Control C. That's why it is exited. Otherwise, it will be running. So our HTTPD server will be now, see, it will be still running, right? If you just put in your browser also, the container is on my server, right? On my machine, the container is running. As it is internet or publicly globally accessible, if you type this IP address on your machine, you'll also get this page. You'll also get this page. Just type 43.204.24.38. You'll also get this particular page available on your laptop. Okay, now what I do here. So what is the benefit of using this one? Again, I just used port 80 to access it. Suppose I want to create another container having a different port. So how I'll do that? You can simply have to, let's go to that. What I have to do, simply use, here I'll use the command. Let's clear it out. Okay, let's clear it out. Okay. Use Docker, right? And container run -d detach mode. I'm going to run. Give a name. Okay. Save Q and publish the port. Suppose 82:80. Means the container port is default is 80. You cannot change it. It will be default 80. You cannot change it. I'm changing the host port. Through 82, I can access my container, right? Through 82, I can access my. Just now give HTTPD. I'm going to use HTTPD. And if I don't specify any tag, it will get the latest tag, right? Hit enter. So it created another container. Within the fractions of second, our application is deployed. Within the milliseconds, right? If I just do Docker container ls, just do ls only. See, we have two containers are running. Web app 1, web app 2, right? And this web app 1 container is forwarded to port number 80 to host port, and this is forwarded to 82. Now, how I'll access this container? How I will access this container? I can just go to the browser, same IP address, okay, because it is running on the same host machine, right? Put the same IP address, but here we have to give port number 82. See, it gives 82, right? Port number colon 82. Now I have two containers running on my machine having four different port 80 and 82. 80 and 82. Two containers are running. Now let's do some changes. If I just want to do deployment of something, copy some index file, right? It is running on that, right? What I do here, let's first go inside a running container. How we can go inside a running container? Suppose this is the container. I just want to go inside this container. I'll do that. I can use Docker exit hyphen it. Docker exit hyphen it. Then provide the container ID here, and then provide the bin bash. Hit enter. See, now I just came inside to the container. See, this is the container. I came inside to the container, and this is a working directory where I am currently. If I do ls-l, so these are the files available in this directly Apache 2 of this container. Okay, now let's come out from this container. Okay, this particular container is having our
Rajit, I want to know how much RAM and how much storage it has taken. So, can you use the command of dh-h and see the memory and the storage of how much it has taken? Because we have not allocated any storage and memory while initiating that container, right?
Yeah, you don't have to necessarily see. I don't have to necessarily do that one, because it will be automatically, as I said, right? Whatever memory is required for the application, it will get directly from the host operating system. But still, there is an option to allocate some memory. I'll show you in the next upcoming classes. Okay, don't worry about that. There, I'll show you how you can set off the CPU usage, how you can usage RAM memory usage and everything. Okay, everything we can do the setup. But if you want to do how many things they are using, there is a different commands are there. I'll just show you. So don't worry, guys. Everything I'll show you. Okay, Docker using top command, Docker top, and just give this particular. So it gives whatever the details we use and all. There are many other commands. I'll just go through this everything. Right now, if I just do anything here, Docker container, use help here. Docker top display the running process of a container. Okay, and Docker stat displays the live stream of the resource usage utilized. You have statistics, Docker statistics, right? If I use Docker instead of top, if I use statistics here, stats, right? See, CPU, this is memory being used. This is the percentage and networks, blocks. Understood now, right? This is how you will do. So there are many commands we are going to learn slowly. Okay, don't worry. Let's come out from here. What is the command? Now, so if I just do Docker container ls, so these two containers are running, right? I want to do some changes to the index file, deploy a new index file. How I'll do that? Suppose bi index.html. I'm just going to create one index file quickly. HTML. So I just created this particular index file. Okay, I created particular index file in my local machine, my server, right, on my laptop. Now what I do, I just want to deploy to the container. I want this particular to copy to the container, this particular index file. I'll do that. What you can do, oh, I forgot this file, whatever it is. I need the path. That's why I went inside to get the path. Okay, path will be there. Wait. Okay, I need this particular path. Got it. Use your local Apache 2 docs. Now what I do, I need to copy this. To copy this one, we can use Docker container CP, or you can use Docker CP directly also, right? No problem. Docker container CP, provide the file name, suppose index.html, I want to copy. Where you have to copy? To the container, right? Give the container ID or container name. Suppose this is the web app container I want to copy. Just give web app to either container ID or container name. Give the path where you want to copy. I just st docs. Here I want to copy this index.html file. Hit enter. Now the file is within the milliseconds it copied. Now if I go here and refresh this page, right? See, our application is deployed. Within the milliseconds, our application is deployed. It's very simple, right? I just copied that particular deployment. This is the one way to copy file, but this is not the real deployment happens here. Real deployment, we are going to create our own image and then we have do the deployment. This is not the deployment. This is simply I showed you how to copy that, right? It's simply copy the file. And remember, this copy can work only for a running container. The container which is running, you can copy the file. If it is dead or inactive, you cannot do that. You cannot do that. Okay. So, and if you see here, port number 80 is still having this old code, still having the old code. But to 82 container, I just copied to new. Okay, so in today's class, we'll talk about all the commands, whatever we have launched, whatever we have in Docker. Okay, I already have showed you as in our first class, like the overview of Docker, the architecture, the installations, and there are a few commands I showed you, right? Today, I'll just give you the complete list of commands. Also, I showed you how you can get the help command to find out all the details about the Docker, right? So let me start all the details. Okay, let me first log into my Docker server. Hope you guys have installed Docker. One of the how you have to do practice, guys. Remember, whenever you are doing practice on any one tool, right? Just get that tool from the get one EC2 instances created on the AWS or Amazon, and just make that server and install the tool for that time until you finish your practice, right? And don't terminate that server. Just start it, install those things, and do practice. And when you finish your practice, just stop it. At the end of the day, stop the server, and what you can do, and next once you practice it, and if you want to terminate that server, you can terminate, and you can create another one and install the other tools on the same server. Also we can do installations for other tools to do the practice. Okay, so I have created already one server, so let me just log into that. So I have created a domain for this docker.com. Okay, so I logged into my Docker server here. Now, what I just want to do, we have to first make ourselves a sudo, right, root user, and let's check if we have any. So, what is the command to check the images? Docker What is the command to check the
Docker PS.
Docker?
Yes. -A.
PS-A. See, that will give us the container details. Okay, if I just give -a, it will give us the container details, but we don't have any container. So guys, this command actually the old-fashioned commands. Okay, don't go with these commands nowadays. This is the old command. Still, it is working, but you should ignore using this one. Though it is very short form to use it, but there is a new command, a new ways to use it is actually Docker. Okay, container is the management command, and then ls-a. Whatever, see, it is little big, but this is the new way of writing the commands Docker has done. So this, they have still both the things. If I just do the same thing, it will give us the list of available containers on the machine. It will give us same thing also. It will give us. Now, if I just do the help, right? Docker help. See, it gives us list of the commands I showed you in our last class, right? So here is the management commands. They keep upgrading this part. So the management command which you need to manage the Docker, right? So here you can see the management command, we have container. That means we need to manage the containers. So we have to use Docker container, and with the container, they have few in between all these commands, right? It has few list of commands for container. To get the commands what can be used with this management command, you can just use Docker container help. If you forget the command and you want to just have a look what are the commands available, just hit Docker container help. So it will give you the list of the commands available to be used with the management command. Okay, available to be used with the management command. So here are the commands. Here, see, manage command is Docker container, and then you have to use few commands here, and these are the commands which you have to provide or pass, right? Similarly, I just provided what? Docker container, then ls, list containers, fine. And if you again want to get the details about ls, then use Docker container ls help. So it will give you again what are the argument you need to pass with ls. Got it, guys? Clear? So that is how you have to use it. Now, to check out the images, right? To manage the images. So the command will be
Docker image.
exactly Docker image. So the management command will be image.
Docker.
Manage image. Right. So to find it out, what is the images available in my system, what I can do, just use Docker image.
Yes.
See, these are the images available in my machine. Right. So what you can do here? This is the command you need to use. So in our last class, I showed you how to get use the pull command to pull some images from the registry. Right. Suppose you want to create one any like Apache server or Nginx server or anything, right? So what you can do, you can just use Docker pull command, right? Docker pull and provide the image name, which image you want to pull out. Suppose I will just pull Nginx. And if you don't know the Nginx version, what you have to do, you have to simply go to the hub.docker.com, right? And search Nginx if you want a particular version of Nginx server to be used. See, Nginx Docker official image. Click on this, and you'll find go to the tags, and you'll find all the tags which are available to be used. As per your requirement, you have to choose which. Suppose 1.24 I want. So what you can do, you can select 1.24. Okay. If you hit enter, so it will download this particular Nginx server with the tag 1.2. So guys, if I don't provide this tag, what will happen?
It will pull the latest one.
Exactly. So it will pull the latest one. So these things, it's very small things to know, but still you have to remember all these things. Maybe you get questions on that. And suppose if you're working on some project, don't forget to pass tag. See, in the real time, whenever you are working in the companies, all right, in your project, you have to make sure that you are providing the accurate tag for your applications or for your project. Otherwise, it will impact the work, right? Impact the applications. Now, if I just do Docker image ls, so it will give us the, see, Nginx latest tag has been downloaded. Nginx latest tag has been downloaded. All right. So in this way, you have to use the pull command to get it. Now, if I just want to see, right, what is the Nginx, the layer of Nginx image, right? So the layers. So what is the command? To use that image, okay, just type history, and give the image name or ID. Suppose I'll give Nginx ID here. See, it gives us the history. When 2 weeks ago it was created, and these are the commands being added into that. Okay, these are the nothing but the Dockerfile. So in our Dockerfile class, we'll discuss all these things. Okay, for the time being, just ignore this part. But you can just remember this history command you can use to check out the image history. Now, to find out the list of commands, you know how to use it. Just Docker image help, and if I go here, you can find the commands how to use it. Right? Let's clear it out. Now, there are, as I said, there are a few commands. Let me let me check this one. Okay, to work on this containers, let me just first create a container. Right? So what I can do, remember, to create a container, we have to use Docker container, the management command, then run. Right? If you want any images to be used, guys, if you are using web applications, web-based container, if you want to web-based applications want to be used or deployed, then you have to definitely publish a port in order to access through the web browser. Remember this point. Okay, if you're just having the standalone and the desktop applications kind of things, which will be like the containers you can access through that, then you can go with directly without publishing the port, without a port you can use it. So I'll just give you an example of, suppose I want to get one Ubuntu machine, Ubuntu container. Okay, so for that, let me search for Ubuntu here. This is Ubuntu, right? Let's go ahead, and this is the command to pull out the Ubuntu latest version. So if you want to get Ubuntu 20.04 or 22 versions and all these things, you can go ahead and see 23.10, 18.14, all these things are available here. 22.04, right? 22.10, 20.04. Suppose I need this particular 20.04 versions or 22.04. So what I have to do? Let's use this Docker container run. Okay, and what you have to do? You have to provide a name to a container, right? Just provide hyphen name. Suppose I'll give my its name to Ubuntu machine, something Ubuntu container. So Ubuntu and something like this. Then you have to provide the name, right? So you provided a name, then we have to provide the image name. So the image name is Ubuntu colon the version, the tag you have to provide 20 point, what is the tag? 20.04, right? 20.04.
Docker. It is Docker.
Yeah, so it should be Docker. Now, so run hyphen name. So I just want to run, suppose in the backend, in the background. So you have to use hyphen D in the detached mode. Okay, hyphen D in the detached mode, and then name Ubuntu cont and the image. If you don't specify this, then it will create the Ubuntu container with the latest version of Ubuntu. Right? Now let's go ahead and hit enter. So okay. So can anyone from you tell me what will happen if I hit enter here? Just tell me the flow, the cycle of this command, run command, how it will work.
It will start pulling the image in the background.
Exactly. So first, what will okay? That's the what it will do. Why it will do? Because this Ubuntu image is not available locally. So what this command will do? This command will first scan for this image locally. The way you have to answer like this. This run command will first scan this particular image locally in the server. If it is not found, what will do? It will pull the image first from the registry and then create container out of that. Right? That is the way you have to answer it. Now let's hit enter. See, unable to find image locally. Right? This image is not available in this machine. Then pulling library from the library. Right? So it pulled after that. What it did? It created a container. Now if I do check the status of the container, Docker container, right? What I can do here, ls. See, it doesn't give me anything, right? So if I do ls-a, so what happens here? It gives us the command or this particular container details. This container is created, but it's exited. But it is exited. As it is just the command, the entry command, entry point, or the command, whatever is given, the command is only bin bash. That means whenever this type of image you are going to use, you have to pass something to be executed. Okay. Now let's execute the same command again. Okay. But remove this particular name or give one more, because see, if I give the same name, what will happen? It will give us this container already exists. See, hit enter. So there is a conflict. The Ubuntu cont is already in use. So same name you cannot give it, even though the container is exited. Okay. So what we can do instead, we can just give a different name to it, right? Suppose I'll give one, and then I can just pass something here, some command, because the command entry point, it has given the command line, it has given bin bash. I am going to pass some command here. Suppose I'll give the Unix command called as imname, right? It will give the name, complete details about the container, okay, the machine, the operating system, right? Okay. So what happens here? Okay. Anyway, you should not use it in the. If you are going to use the, let's remove the name unnecessary. We have to edit all the time. Hyphen D, you should not give it. Okay. See what happened when we created the container. What will happen? We created the container and then it executed this command uname. It's called Linux. It gave us Linux, right? Suppose you will give uname hyphen a. See, it gives us all these complete details about this uname hyphen a. Okay. Now, if I just give pwd here, it gives us root. Okay. So if I do locally pwd, it gives us sorry. But here, if I could give pwd, it gives us this one. Now let's see how many containers will be created now. If I just do container ls-a, see, I have lots of containers created, and these are the commands being executed, right? I passed uname first, and then uname hyphen a, then I passed pwd to be executed. So what happened here? It just created the container and then executed this command. Now, this is what simply I showed you, creating the command, creating the container and executing the command during the runtime. But sometimes you want to go inside this kind of container. So what we'll do here, just use hyphen run, okay, run hyphen it. See what will happen here. The container, what happened here? When I used hyphen D or without hyphen D any options, what happened is just created the container, and whatever the command we pass it, it's just executing it this done. But when I use Docker container hyphen it, what it does, it go inside to the container. It attached to the container. I was using -d is a detached mode. That means it will just create the container and it will detach out, right, with executing the command. But here what I'm using -it interactive mode to attach to the container. You can see here, I just go inside the container. I went inside this container. Now, if I just do pwd inside the container, we are into the root directory, and that is called the working directory here. Okay. Now, here you can do whatever you want. Any command if you want to execute, you do the pwd, you can use uname here, because this is the Linux machine we created, Linux container. This is a Linux container. See, I'm currently inside to this container, right? Now, if I just log into another terminal and check, right? If I just log into another terminal and go to the container and check, let me just quickly log into the machine again. So, terminals. Okay. So here, if I do Docker container ls happen, only ls. See, this particular Ubuntu container, right? This container, Ubuntu container, is about a minute up. It's not exited because we are connected, attached to the container. So when I come out from this container, if I just go ahead and check it here, it will not be there. See, it's exited. It's now exited, right? Now, I'll ask you one question here. So, what are these names, guys? Pensive, Napier, Focused, Darwin, Practical, Vaughan, and Jolly Novel. What is these names? We have not provided any name, right? We had provided this and this. What are these names?
These are Docker mentioned names actually.
Exactly. So remember, guys, whenever you don't provide any name, then Docker will automatically assign any name randomly to the container. Okay. So these are the names. So always make sure whenever you are working in your project, make sure you are giving the appropriate and the required name to the containers. Okay. That's all. So we just checked it out, all these container details. Now let's go ahead and okay. Here I'll give you a few more commands here. Suppose I have, so how to delete a container or remove a container. So there is an image called Docker. You can directly use Docker rm, that's the old fashioned command to delete it. Though old fashioned, but short command to delete it. Okay. But now if you're going to just use Docker container rm, remove, right? Suppose I just want to remove this particular. Give rm container ID or the container name. You can give Pensive Napier here. Then hit enter. So it's just deleted the container. So if I just do check here, see this Pensive Napier is not there. All right. Now here single container I deleted. So if there are multiple containers are there, if there are hundreds of defunct or exited containers are there and you want to delete, you cannot do 100 times this complete one single command to delete it, right? Instead, what you can do, you can just write this particular here, and what you can do okay. Before that, let me show you. There are one more command, ls -a, and if I do aq, what it will do? It will give us only the container ID, not all the details. Okay. See, it gives us only the container ID. It gives us only the container ID. So now let me show you how trickily you have to use. So this command gives us only the container ID, and this command deleted the container. Okay, this command actually deletes the containers, and this command gives us the list of the container, or gives us the list of the container IDs. Okay, now I need to combine together these two commands in order to delete this particular defunct or exited container. So how I'll do that? First, I want to delete it, suppose, right? Now Docker container RM. Now I need to pass these particular things to the RM command in order to delete it. So I can just create one more subcell here, and inside this you can just put all these commands. See, got it? What happened here? Docker container RM, and within this subcell I created one more command. I provided docker container ls-eq. So what it will do? It will generate the list of container IDs, and then these container IDs will be passed to the input to this command. Then it will remove all this. It's hit enter.
Container.
Okay, container spelling mistake. Sorry. So we have to just provide container here. See, it's just deleted everything. Now, if you want to check whether any containers are available or not, see, nothing is there, right? Nothing is there. Everything is deleted. Now, this is you have to work on.
So this is the command for deleting all the containers, right? But for example, we have 100 containers, only 50 in between some containers available, right? So those kind of scenarios.
Yeah. No, sorry, I didn't get you. Can you come again?
For example, 20 containers there. Okay, so if you use this command, the 20 containers at one time will delete it. For example, I need to delete only the number 8 and number 12, number 15. So those kind of containers. So
yeah,
you have any command or one by one you have to do it again?
No, there is no specific command. One by one. Okay. One by one you can use it because that Docker does not have that facility to do it, and even nothing will be there. But what you can do, you can write a code for that, script for that. Okay, suppose you want to, suppose there are all these commands are all are exited, right? So let's talk about this, and you want to particularly delete the container which name is, suppose, Jolly Novel, right? If you don't want to single delete, or you want to just delete the containers which see, there will be, suppose, 50 containers will be there, and 20 will be up and 30 will be exited. Then you have to select. What you can do, you can use some commands, like if I just use anyway, these containers are gone now. So what you can do, you can just use this command, and then you can use what? Grave exited. Then it will give you that particular line what you need to be deleted, and then you can just use -q to get this particular. So if you're good in the scripting, then you can do whatever you want. So I have already few scripts with related to Docker also. I'll show you how we can use that and how.
Ranjit, like the Docker container names like Ubuntu count and Ubuntu count one you are given, so that is the name it is created. So whenever we have not created the container name, so by default it is created a name called focus Darwin Jolly. Yeah. So these names you are saying like it will be get from the image was created, or
these names will be given randomly by the daemon, by the Docker daemon.
Okay.
Server.
So it based, I mean, it will randomly give based on the. Based on what, actually?
No, it actually not based on anything. It is randomly gets provided by the Docker daemon. It does not depends on any kind of image or any kind of anything. Suppose you create any other server, right? Let me tell you one more thing. Suppose I'll just use Docker container run bgbox. Okay. Run bgbox. So bgbox is the image name. I'm just going to create. So quickly it will just download and do that. So now our container is created, right? So if I just choose ls-a, it will be there. But how it gives it randomly? It gives it gave a name, right? Randomly it gives a name to it. It does not matter that which image you are using. It will first, the daemon will check where the client, what the client has sent the request. So the client has sent the request Docker container run bgbox. That then client has requested to create a container from this image, right? The client has requested to the daemon. Then daemon will get this response and check whether the required parameters to provide a name has been provided or not. If the name parameter is not provided, what it will do? It will assign automatically a name to it by its automatically, dynamically, by its logic. It will just put it. Suppose if I provide a name to it, right? Something like that. So what happened here? Now it also created a container, but it will have a name. See, I'm busy. So what it does, the Docker, when the client provided this request, Docker daemon receives the request and checks whether this particular parameter is there or not. If it is there, then it will create container name. If it is not there, randomly it will assign. Okay, now let's move on and work on few more containers. Let's go ahead and work on the wave container, one of the wave containers. Suppose I'll go with the HTTPD container. So to get it out, this HTTPD container, so what you can do is Docker container, right? What will happen here? Use run -d. Suppose I want to run in the detach mode. Then what I can do here, use -name, give a name, suppose web app, I'll give a name to it, and the image name, suppose I'll use HTTPD. I want this latest version. Okay. As I said, if I just create this particular container, what will happen? Let's see. Okay. So we can able to connect to this container, right? The container, we able to create the container, right? So if I just do Docker container ls, right? See how this particular HTTPD image, this container is running, it's up and running, and the port is 80. So what is this port? This is the container port. Remember, this HTTPD is nothing but the Apache server, the name of the Apache server. This image is the Apache server, and Apache web server default port is 80, and it has the 80, but this 80 port is the container port. If I just try to connect this one from the Docker dot, suppose I do ranjitsmine.com here, hit enter. See, this page is not reachable. I'm not able to connect to the container. The container port has 80. Why I'm not able to connect? Because see, the container is up and running, but I'm not able to connect. It's because I have not forwarded this container port to the host port or publish. We need to publish this container port to outside so that we can able to connect from the internet, right? So to do that, what we have to use? We have to simply use, and we have to simply forward the port, right? We have to simply forward the port. Let me just remove this one, container rm, and remove this container first. If you don't remove, that's okay also, but I just remove it. Okay, so what happened again? It says we cannot remove a running container. That could be again question comes. Can we remove a running container? No. We cannot directly remove it using the rm command, but forcefully we can do it. Simple with rm command, it will be not possible to delete a running container. If a dead container or exited container, you can delete it, but this cannot be deleted. So how we can do that? How we can delete this? You can just simply use rm-f forcefully. Okay, -f. See, it's now deleted. If I just say, see, nothing is there. Now let's go ahead and create the same container, but this time publish the port, right? So to publish the port, you have to use -publish, or you can use short form -p and 80 colon suppose 80. So what happened here? I used here 80 colon 80, right? So what is this? This 80 is the container port, and this 80 is the host port. That means I am forwarding or publishing the container port to the host port so that we can connect to the container from the outside world, right? So in order to do that, let me just change the host port to suppose 8080. Okay, 8080, and make sure this particular port is whitelisted. Otherwise, it will not work. Okay. Now, what happened here? I have just forwarded or published this container port to the host port here. Right. Now, let's hit enter. What happened here? It created the container. Now, if I just go here and I just provide colon 8080, right? Colon 8080. See, it says it works. It says it works, right? Now, if I just go ahead and suppose I'll create one index file quickly, index.html. Should have keep one HTML file ready to do the demo. Okay, I simply just wrote one very small index file. Let's save it. Okay. Now, my container is running currently, right? So if I just do Docker container ls, so the container is running, and this is the container ID. It's up, right? About a minute, it's up. Now I can also access the container here. Now that could be question comes how we can copy some files to a running container. Okay, to a running container, to a container. How can we copy to a container? So to do that, we can use Docker. Either you can use the old version copy directly here, or else, sorry, CP directly here, not copy, CP, Docker CP, or you can use Docker container CP command. So you know how to get these details. If you don't remember how to copy a file, you can just do Docker container help and you get the command details. Okay. Now CP, right? Now what I can do here, pass the path where index file.html is there in the locally available in this particular directory, right? C2-user home directory, and I want to copy to the container directory, right? To the container directory. So the container directory will be, let's copy this one, colon, you have to pass. It will be, I think, user, user home attached. Okay, okay. I don't remember now. Let's first go inside to the container to find it out. Okay. Now leave this part. I'll do it just within the seconds. Now what happened here? The container is running. Suppose I just want to go inside the running container. So what is the command? You can just use Docker container exec, okay, hyphen it. Remember exec command, okay, to a running container exec hyphen it. Then provide the container name or container ID. Suppose I'll give your name. You can provide either container ID or name. Then pass a command bin bus. Okay, hit enter. See, now I just entered inside the container. See, this is the container ID, root container ID, and you can see here I am landed into the working directory. And if I do ls here, ls -l. See, these are the folders available in this container. I went inside the container. Why I showed this command before this? Because I need this particular path in order to copy the file. I forgot this particular user local Apache 2, right? So you have to just copy this anyway. Let's come out from the container. I came out from the container. Now let's execute this cp command. Okay. User, it should be local Apache 2 : and I need to copy to this htdocs folder, to the htdocs folder. So htdocs. Hit enter. So now our index file is copied to the container, right? If I go here and refresh, see, our application has been deployed. See, just copied the index file, I copied it. Welcome to the Docker class, or whatever was given. Now, this is what simple copy file, right? Now, in my earlier example, earlier command, right? But I went inside to this one, right? If I go now to this here and go to the htdocs, here if you want to do some troubleshoot here, you can go here, and here you can find this index.html. And if I do cat index.html file, you'll see whatever things I had written. See, these are the things and inside the container. If you want to change this one, just use the vi command and edit this file here inside the container itself. Okay, I believe this command just index.html. Okay, so vim command is not available inside com, so you can use instead nano index.html. Even nano command is also not there. Okay, fine. So this is how you have to just go inside to a container, and whatever things you want to do and troubleshoot, you can do that. Now, come out from here. Now, there are a few other commands available, like the log, status, right? Stat, top command on it. So if I just do docker container logs, okay, and give the container name. Suppose I'll give web app. Sorry, it's not log, it's logs. I missed S. See, it gives us the, if I just do docker container logs web app, the container, it gives us the log of the container, running container. Okay. Now, if you want to just check, get a running container, what will do? You can just use logs-f option. So it will attach to this logs, and if I just do anything to this particular browser, suppose I do refresh, right? Let me just you can see here this particular log will increase. Okay, if I just refresh, see, some request comes, right? That's why the logs is being written. So this is how you can just write the logs, right? You can write this particular docker containers logs-f to attach to the logs, so that you can this is actually to display or to see the flowing logs of that particular container. You can just use this particular information logs. If you want to see last 10 lines of the container, just use logs web app, it will give you the details. Now if I just use Control-C, I will come out from there. Okay, now this is the logs command. If you want to just do the status, the memory, the CPUs, okay, how much memory, how much resources being used by the container, right? How many resources being used by the used container. So you can use docker container stats, okay, and the container name or ID. See, it gives the container ID, name, this CPU being used, memory being used, limits this much memory, and all this. Okay, this you can go ahead and use it. Now, if you want to see the CPU details and more usage and all, so you can go ahead container and use top command. See the PID process and what are the time being used and all these things you can get, right? This is all the management commands, and if you can all these commands you can find it out here. Container help, we can just see the exe command, we just create. We have not create a new container. You can use it. Create commit. We have not attach. You can attach to a container. Okay. Stats we saw top, start, stop, restart, rename a container. If your container you have given a web app, you want to rename it, you can just use it. So it's a very simple things, guys. I just don't want to go each and everything. So it's very basic thing. You can just do practice. So it asks for you just do and play around all the commands and all the explanations also given it here, right? Start, stop, wait, update, pause, everything just commit, attach, everything you can just go ahead and work on that, right? So there are few other commands which we can go ahead and use it, like kill to kill a container running, right? To port list port mappings or specific mapping for the container. Suppose you want to find what are the ports being mapped, you can just give container port. It will give you, see, this is the port which is forwarded. This is right. So that is how you have to find it out and why. Done, guys. This is all about command, and you have to, any things you have to use first. Check out that particular management command, and then use help option to. Suppose you want to get more details about the image management command, use image, then help here. See, you'll get these are the very few commands being used with the image. Anyway, we'll go and see all these command details and everything.
I could see a command called like pause and then restart, something like that. So this will be used in which scenarios? Like, so you're pausing and what kind of action they will take, and then the restart they will do.
Yeah. So see, in case of suppose you are doing some kind of activity and you want to stop something and pause the container, then you can just use that to stop this container, right? Let me suppose show you here. Suppose we have this Docker container, this particular thing's running, and I use Docker container. Okay, let's help. What it says actually, pause all processes within or one or more container. So it will pause the processes whatever is running. If you want to stop it, there will be a stop command. See, stop. Stop one or more container, running container. If you want to stop it, if you're doing, suppose the scenario comes, you are going to do some kind of activity or some kind of things, you are going to do that. And you don't want your container to be affected, you can stop this container, right? You can stop this container. Suppose you have multiple, one container is AI, UI container, another is database container, all are attached, and you want to do some maintenance on the DB part and you want to stop this. So you can stop the container, and then once it is done, you can start it, right? So this is where you have to use stop and start. Suppose I just want to stop it, so what you can do, stop wave off. So the container is now stopped, okay? So if I just refresh this one, see, the container is stopped. And if I just do Docker container ls -a, see, this particular container is exited. Stopped means it's exited. It will show you exit. And if you want to start it or restart it, just use start. And if I do ls-la, see, it is now up. It is now up, right? If I go ahead and restart it, replace it, see. Okay, guys, so I'm not going to waste more time here to show you. It's very simple things. Go and just do the practice, okay? Whatever things is written, everything clearly. So just do practice of all the because there are multiple commands. If I go each and every command, simple command, then it will take time and we cannot cover it, right? So the task for you to do is create the container and do all these things practice, okay? And we'll have question answered maybe in our next upcoming classes. Fine. So we are good with this. Now let's talk about, okay, so far whatever we have worked on inbuilt and default images. So we got the images from the registry and worked on that. But some cases, not some cases, but in your company, in your organization, you don't have to exactly get the images from the registry and work on that. No, you have to write your own image. You have to build your own image and then you have to create a container. That is how the companies we work, right? So far, I was just giving you how we have to deal with the container and images and all these things. But now let's talk about how we can build our own image, how we can create our own image. Okay. Before that, we need to understand the concept of the Docker file. What is the Docker file? Because this image writing, right? First thing, what is the image? It is a template or recipe, or it's a list of instructions given to create the image and to create the container, right? It's a template. It's a recipe for the container to run. It's a list of instructions given in the image, right? To use that image, to create that image, we need to write these things in a file. That's called the Docker file, right? Let me just explain you all this. What is the Docker file? We have so make your own image, Docker file. What is this Docker file? So a Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. So as I said, the Docker file is a text document and it will have all the instructions. It will have all the list of the commands which is required for the image to be created. Okay. To create that image, we need to use the docker build command to build an image from the Docker file and a context. I'll just explain you what is this context when we do that one. Okay. So the Docker daemon runs on the instructions in the Docker file one by one, committing the result of each instructions to a new image if necessary before finally outputting the ID of new image. So when we provide the instructions to create that image, the Docker daemon will run the instructions given in the Docker file. Let me show you one example of a Docker file. If I just go here to my GitHub page, I'll have multiple. I'll just don't go now and check it unless we finish it, right? I have few Docker file here. One Docker file is there. See, this Docker file has given written few steps here. Few steps. Okay, few steps. These are the instructions. Okay, these are the instructions given in the Docker file. And what the Docker file, as it says, is a plain text file. It is a plain text file. Docker file is a text document which should not have any what do you say? It will not have any extensions to it. Simple Docker file, and D should be in uppercase. Okay, I'll show you how to write this. Okay. Fine, this is the command, and whenever possible, Docker will reuse immediately images from the cache and to accelerate the Docker build process significantly. So, if the image is already downloaded, then Docker image, if you Docker build option you are using, then reuse from the cache, means whatever things is downloaded and used, then it will create the image, newly image, right? So what I can do here, just use, let me show you here. To use the Docker file, now you'll be thinking, right, how we can use this Docker file and all these commands and all, right? How we can do that, guys? You can simply use this docs.docker.com. Okay, go to reference or manuals, whatever here, or get started. You can just click it. Okay, click this get started. Here it gives the what is container and all these things, images and all these things available here, all the details. Okay, but now I need to focus on the Docker file. Now I need to focus on the Docker file. There are many other things are there that I'm going to tell you everything. That data persistence, binds, multi-container, DockerCompose, everything I'll just go through step by step, part by part. Okay, don't worry about this. So far we are working on this containerization application. We already see how we can containerize the applications by creating the things, right? Let's talk about the Docker file now. Then we'll talk about more on this, right? So just go to the reference here, and in this reference, okay, go to the reference. In this reference, we have Docker file and Compose file. First, focus on the Docker file, and then maybe tomorrow classes we'll talk about the Compose file. Okay. Now let's go to the Docker file, and here you can see we have all the Docker command line. Whatever the Docker command line, we get it there, right? You can, if you just click this link, right, you'll find here all the commands. These are the commands, right? Anyway, no need to follow these things because you can easily find it out here itself, right? If I just use help option, there itself you can find it out. Or if you want to read it more on this, just come here and check it out. Same thing is given here, right? Nothing extra. Same thing is given here. Same thing is given here. And these are the environment variables to pass to the, I'll just talk about these variable sections, okay, of Docker, okay, environment variables, how we'll pass this environment variables and all. Right. Now, all these things done. Now, if I just go ahead and check, right, the Docker file, let's go to the Docker file here first, go to the Docker file. So here is the Docker file difference, right? Docker can build images automatically by reading the instructions from a Docker file, reading the instructions from a Docker file. So here the instructions is given, see, and how you use and find the command. Here the list of commands in the right side you can find it. Always I said, guys, whenever you are working on any tool or any technologies, always follow their official document pages, official documents, because they keep upgrading their application, their tools, and they keep updated their document as well. And they could add, modify some commands, they could add new commands, right? They can deprecate some things. So which everything you can find it from their documentation. And you have to follow this. Even I use frequently whenever I just work. Because we are human beings and we cannot remember everything. There are multiple things in the market, right? We cannot remember everything. So we have to follow the documentations and find it out, whatever things we wait. Let me show you some simple commands, simple ways how we can write the Docker file. Okay, how we can write a Docker file. Now, let's go ahead. As I said, when you write a Docker file, when to write your own image. First, let's understand when to write your own image. If there is a requirement comes to the development or DevOps info, as a DevOps engineer, the requirement comes to from a development team that you have to deploy certain applications with sort of configurations, right? So first, what you have to do, you have to create your own image, right? To create your own image, you have to first create a context area, create a folder, right? Let's create a directory here. Suppose app cd app. Now I'm into this particular directory. Now this particular directory and this particular folder will be my context area. Now context area means where you execute the build, where your Docker file will be available. The folder directory, that path, that area will be your context area, will be your context area. So this context area, you should not keep everything, you should not keep the things which is not required for the image to be used. Because if you put some unnecessary things in this folder and you execute the Docker build command, what will happen? Everything in the context folder will be wrapped together to create the image, and the image will become heavy. The size will be increased. Hello? Yes, can you hear me? Hello? Okay, guys. So, as I said in our last class, right? So we are going to write our own image. We are going to build our own image. So far, whatever we have worked, we worked on the inbuilt images provided by the Docker Hub or Docker registry, right? So here we are going to see in real time in your project, in your company, right? You don't have to actually dependent on the images, default images or the inbuilt images being provided. So you have to write your own image based on your requirement, right? Based on your deployment strategy, based on your requirement, based on your application, you have to write your own image. Okay, so to write your own image or to build your own image and create your own image, what you have to do, you have to write these instructions in a file that's called the Docker file. And make sure that Docker file, whenever you create the Docker file, and you have to keep in a context where the context is clean and the required files for the images to build, you need to keep it there. The unnecessary junks, unnecessary stops, you don't have to put it there. Otherwise, it will increase the size of the images unnecessary, right? So let me just log into the Docker server. Okay, so I just connected. Now what we can do here, so if I just do Docker image ls, you can see we have few images available here, right? And if you want to just delete all the images, what you can do here, uh, either you can do image rm and delete one, or else what you can do, if I just want to ls-q, here we can get this image ids, right? So in our last class, like yesterday's class, I just showed you, right, how we can delete all the exited container, or all the defunct or the date containers at one time, right? If there are more than 100, more than 10 there, you cannot do one by one, right? So you can together in the group bunch, you can just delete everything, right? So what you can do, you can here also write Docker. So the command is to delete image rm, and here you can just create a subcell, and inside this subcell you can just put the command which provide the image id. So it will be docker image ls-q. So this will provide us the image id, and that will be passed as input to this one. So it will be deleted everything. Now let's hit enter. Good. So everything is deleted, but one thing is says like error response from the daemon. Conflict unable to delete image is being used, right, by a container. By this container is being used. Now let's check which container is running. Docker container ls. So we have this container which we had done the demo yesterday. It's still running 24 hours ago, right? 24 hours ago, it's still running. So let's delete this container first. Okay, delete this container first. Or if you want to forcefully delete that image, you can still do that. So how you have to do, you have to just use rm-f, right? So for safer side, just delete the container rm-f. Again, it's running, so forcefully we have to also delete it, delete the container. Done. Now we can delete the image. Unable to delete must be forced. The image is being used by another container. Okay, that should be another container, maybe bgbox, I think. Docker set container ls-a. Yes, the bgbox thing. Okay, these are things there. Let's forcefully delete rm-f. So delete it, right? This is the way you have to troubleshoot and you have to work on this. Okay, now leave this part. Leave this part. So what I was
Ranjit,
yeah.
one question, like, so one image will be used by multiple containers, right?
Yes, you can create
Okay.
n containers. You can create n number of containers.
Yeah, for example, like we have one image, so that image can be used by 2 or 3 containers.
Not 2 or 3 containers. You can create n number of containers.
Okay, okay.
You can
Because
create.
like in this case, like there were one image, so it has been used by BC box and that HTTP one more container, right?
No. What you saw, the BGBox was using by other image, BGBox image, and the HTTPD was being used by the HTTPD container, the Apache server container. That's totally different.
Okay, okay. But when you try to delete the HTTP container, so you are not able to connect, right? So it's showing image is used by other containers, some error we receive. Right?
Because that HTTP container was also running, right? When I deleted the HTTP image, right? When I deleted the HTTP image, it threw error because the HTTP container was still running. It's still there.
Okay, then in the case we need to stop the container and then delete.
Yeah. Then I deleted the container first and deleted the image, right?
Okay, okay.
After then, when I started deleting the image again, then I found error of BGBugs. Then I saw that there are also a container of BGBugs. Right?
Okay.
I deleted the BGBugs container and then images forcefully, right? So that is what you have to do. Okay. Now, yesterday I was showing you to write the Docker file, right? So what you have to do, and this is my context area. Correct. So what you can do here, if you see here, we have this PWD and we have this app, this particular folder. We don't have anything available here. It's clean, right? This is totally clean. We don't have anything here. Now let's create a Docker file. So how we have to create? Just use Docker file, D uppercase. Okay. Now hit enter. Okay. And while writing the Docker file, let me just show you the Docker file thing. This is the Dockerfile reference, right? So you have to follow this reference, and here you can find the command list, right? The command list where you can get it. And remember, when you start the Docker file must begin with a from instructions. What happens? You just read this. The instructions is not case sensitive. However, convention is for them to be uppercase, distinguish them from the arguments more easily. That means whenever you write these commands, make sure that you write in the uppercase. What it says is not case sensitive. That means you can write the lowercase as well. You can write the lowercase as well, but to make it distinguish them from the arguments more easily, we can make this in uppercase so that you can distinguish that these are the commands being used in the Docker file. And Docker runs instructions in a Docker file in order. It means in sequentially, in order, one after another, it will run. So a Docker file must begin with a from instruction. So the from instruction is the base image. That's called the base image. Okay. Now let's give an example. Okay, before giving an example, let me just show you how you have to write it first, and with a small example, and then we'll move into the other complicated and the complex examples, and we'll see how it can be done. Okay, now, so my requirement is to just create an image which will create a container to execute a script. Right? Now, what I can do here to execute a script, suppose I just want a small Linux box, Linux utility. Suppose the BusyBox will be the best suitable for us, right? So I need the base image. That's we have to write the from BusyBox, right? From BusyBox. So the base image I'm going to use it BusyBox. On top of that, I'm going to add a few more layers. Okay. So let me just show you here. It's very simple things there. I'm going to give you these examples here. Okay, I'm going to show you this example to you. Now, what happens here? From BGBox, I'm going to copy a script. So, what is the script name? Test.sh. Where to copy? To var. Right? Now, what I'm going to do? Let's copy. So, copy is a command. But in Docker command line, the copy command is cp, right? Docker cp and copy the file to the container. But here in the Docker file, the command is copy. So I'm going to copy this. What I'm going to copy? Suppose I will copy test.sh or something like app.sh to tmp folder, right? And let's make this tmp folder as my working directory. So I'll make it as work_dir slash tmp. So this tmp will be my work directory. So what is this working directory? The working directory, whenever you create a container, right? Whenever you go inside container, you used to see, right, will be landed into the working directory. The first enter will get the working directory. That means when you create the container, the working directory, whatever things are there inside that container, from there everything will be executed, and from there the container will work. The work directory, right? So you'll be thinking, right, where I'll get this kind of commands, from where I can get this kind of commands. So if you just go to the Dockerfile reference, right? If I go to the Dockerfile reference, you'll find there are all commands available here. See what I just used? I used copy, right? See, copy. Then I used what? Work directory. Let's see what is this work directory. See, this work directory, the work directory instruction sets the working directory of any run, cmd, entry point, copy, and add instructions that follow in the Docker file. That means whatever the commands you are going to use, these are the commands: run, cmd, entry point, copy, and add instructions that follow in the Docker file. That means we are going to set that these are commands which will start working from the working directory which we have set up. Now what happened here? I just copied one script to this temp directory of the container, and then from there I'm just giving another instructions. Then make this tmp directory as my working directory. And in the next statement, I'm going to write next instructions to execute the command. Going to execute sh, comma, going to run this app.sh. So what happened? When this command will be executed, this command will executed from this tmp folder, tmp directory. And in this tmp directory, we have this app.sh file. We have this app.sh file, right? Now let's save this one. Now let's save this Docker file. Any doubt, guys? So this is just a starting, right? We have to explain, we have to go further and to understand a bit more of all these items. Okay. So far, did you understand, guys, everything, or you have still any doubt?
Yeah, the copy command, right? So we are copying that app.sh from local to the busybox, correct?
Exactly. Local to the image to the container.
Okay.
Okay. So the busybox on the busybox. So what will happen? How this image will be built? First, it will download this busybox image, right? And on top of busybox image, what will happen? It will copy this app.sh to the tmp folder of this container, busybox image container, and then it will create the working directory, and then it will execute the command. Right now, let's do that. So first, I'm going to copy this app.sh, right, and make sure that this app.sh is also available in your system, right? Now we have this ls. When I did ls-l, I can just find only Docker file I wrote it. Now let's create this app.sh, because that is the file I just need to copy it, right? And I'm going to write something. So what I'll do here, just give it echo. Okay, what it says? I'm just writing an echo statement to print it here. So echo, I am executed from the container, and give me. Let me give a few more example size. Suppose I'll give uh, the current working directory. I'll give it as so the command will be executed as pwa. So guys who have a little bit ideas on the scripting, self scripting, can understand. If you don't understand, let me just explain you. Okay, let me just finish it off and okay. So what happened here? I in this shell script, I just wrote few echo statement to print. What I said, it's just printing small statement here. I'm executed from a container, then current working directory. Inside this, what happened? I just executed a command called pwd here, and here is the back quoted. Inside the back quoted, if you are going to execute within the double quote, then you have to execute like this. Put it to give the command, and here the date. Okay. Similarly, what I'm going to do here, let's save this file. Let's save this file and make sure, like whenever you create any shell script, make sure that you make it as executables, right? You have to give full permissions to chmod. Suppose I'll give plus x app.sh. Now we get this. See, we got this executable permissions. Now, what I need, I got my Docker file ready in this context area, in this directory. We have two files. One is the Docker file, and another is the app.sh, which is required to be copied to the image or the container. Right now, we need to build to create the image. Okay, we need this to build and create the image. Right now, how we'll do that? The command will be docker. You can either use image build or directly build. Okay, so let's do image help. We'll find it out the details. See what it says: build an image from a Docker file. Right now, what you can do here: docker image, the management command. Then the command subcommand, you have to put it as build, right? And you have to put it. You have to give a tag -t and give a name to the image. So you have to give a name to the image, right? I can give like my just my image, something I gave a name to it. My image colon. I give a tag 1.0. Suppose dot. If I don't give 1.0, it will create the latest image, latest my image. Okay. So the image name will be my image 1.0 dot. Okay. Now hit enter. So see the step one, what it does, it just executing this from bgbox. So first pulling this bgbox and just executing it. After that, the second step, what it did, it just see the step two, copy this particular to tmp directory, to the tmp directory, and then step three, selecting this, making it working directory tmp, and then it's just executing this command. So now if I just choose docker image ls, see we have this my image is created. We have our my image tag 1.0 is created. Okay. Now if I want to create a container out of that, right? How I'll do that? Use docker container run, right? And use the image name. What is the image name? My image 1.0. Hit enter. See what happens? It created the container and executed whatever the instructions was provided in the image. I am executed from the container, and the current working directory is tmp, and today's date is even this one, right? So if I just check whether the container is created or not, if I just do docker container plus, so it is exited, right? Okay. So see, we have this my image, this particular container, and it executed the command, this particular script. So this is a very simple to understand, to demonstrate how you can create your own image and execute it. Okay, this is a very small example. Now let's go beyond that and see. So in our last class, what we had done, if you remember, I had created one Apache server. I had created one Apache server, and that Apache server I had used the image HTTPD, right? That image, what I did, I created that image, and then what happened? I copied manually to the running container in order to execute the, or in order to deployment the applications, or deployment the, in order to copy the index.html file, right? The same thing, actually that is the demonstrations I was showing you, how we can do that, manually copy some stuff to a container. But actually the requirement comes, actually how you have to work on this. If you're working in your project, right, a requirement, suppose a real-time requirement comes, you have to create one Apache server. Suppose your development guys have worked some PHP development, some PHP development has been done, or some HTML website, some e-commerce site or something you guys might have developed, and you need that to be deployed into one Apache server container, Apache container, right, HTTPD container. So the requirement comes to you, right? You have to write the Apache server container. So how you have to write your, so we cannot directly create a container from HTTPD server, getting it from the registry. What you can do, you can simply, what do? You can simply get the image file, right? And then you have to add the layers of the instructions as per your requirement. So how you will do that? Let me just create another folder, free complete folder. Suppose I'll just make like another context area, right, where I'm, as per requirement, I'm going to create it. Now let's do that, like web app, something like this. Okay, let me copy this index file to this web, and this is the file I just want to. If I go to web app folder, so we have this index.html file, I just put it there. Now what happened? I just, what I want, I need to write one Docker file. I want to write a Docker file, right? So let's write it, Docker file, enter. So here, what should be the base image? What should be the base image here?
HTTPD.
Exactly. So it should be HTTPD. So you have to write from HTTPD, right? And here, if I do only HTTPD, then it may impact your work, right? So you have to make sure that which particular version do you need for your server, right? For which particular versions do you need for the server? For that, you can go to the, where you can go to the Docker Hub, and
Docker Hub.
there you can find where it is. Okay, there you can find which particular tag do you need for your Apache server. So is it clear, guys? Now, for the time being, let it be HTTPD only, the latest versions. Okay. Now, for better understanding, let me give one versions for you, right? So, suppose I need this particular versions of HTTPD. I'll just search for which tag you have available. Suppose I need 2.4. Okay, I need 2.4. Let's go here, colon 2.4. From this image, particular image, what I need to add, first what I need to copy the index file, right? I need to copy the index file. So let's use copy, right, index.html, okay, to user local, and to the folder where Apache 2, then htdocs. This is the folder where I'll just copy this index.html from locally to this container directly, Now just hit enter. What I do next, I just want to make this particular directory as my working directory. Any directory if you want to make it. By default, the working directory is this one. So I don't need to change any working directory. My simple work is to copy this particular things to htdocs. That's very simple, right? Very simple. Let's do that here. htdocs. Save it. Done it. Now, what I need, I just wrote small, very small for your understanding, and I will just make it big, right? Don't worry. Very small. from, and I just copied this one to this htdocs folder. Now let's build the image. So what is the command? Docker image build hyphen t. I can give web app version 1.0, right? And dot. So why dot, guys? Dot means the current directory. In the this current directory, we have this Docker file available. We don't have to specify the Docker file name here. You have to just specify dot. That means it will just execute the get the Docker file and get executed, right? Now let's hit enter. See, first it is downloading the HTTPD image, HTTPD 2.4 image, and top of that, it just copy this one. Now if I just do Docker image ls, see, we have this web app 1.0 version available. Now what I can do here, I will create a container and let's see how it is working. Okay, what I'll do here, I'll just use let's refresh this one. Okay, anyway, this container is no more there, right? That's why it just cannot be erased. So what I can do here, if I just create another container, if I just go ahead and create another container, suppose Docker container run, okay, and give a name to it. Suppose I'll give name my web app, something like this, right? And give the image name. So image name is web app colon 1.0. Okay. So as it is a web applications and is a Apache server, web server, I need this to be accessed through the web browser, and I need the port to be, so Apache server default port is 80, right? So I need this port to be published or forwarded. So to do that, I can use publish p. Then suppose I'll forward to 8080:80. So this 80 is our container port, and this 8080 is our host port, right? Now let's hit enter. So here, one thing you can notice, guys, I did not specify -d option, detached mode. So what happened here, when I created this container, what happened, it just attached to the terminal, right? We can see the logs here itself. Now, even though it is created and attached, we would have the container created, right? Now, if I go ahead and just use the, see, I refresh this, and with this container and port number 8080, we got our application running. Okay. Now we got our one image version 1.0. Suppose there another requirement may come where you may need to modify something into your application. Need to modify something into your applications. For that, what happens? Suppose either your applications require something, and you have to suppose put one image here. Okay, image into the index.html file, right? Index.html file. So what we can do here? Let me just modify the index.html file first, and then we'll talk about it.
I have a question actually.
Yeah.
While creating an image itself, whether we can able to give the port number, or after creating a container, we have to give the port number.
See, this is where you can just publish the port. Okay,
Yeah.
8080. There you can directly publish a port also in the Docker file, but that's not the way you have to do that. Okay, because see, if you make one port, why that is because, see, your container, you same image, you may create multiple containers. Suppose you can create multiple container. Okay, let me just do that example, then you can understand. Now I just exited this container, right? Okay.
Yes.
Let me give you an example here. Let's go to the Docker file reference, and if I just go here, we have this expose command is there. If you see just expose command, what it does, the expose port, right? See here, exposing the port. Expose instructions from informs Docker that container listens on the specified network ports at runtime. Can specify whether the port. Okay, so why by default actually this expose of HTTPD is 80 because HTTPD run on 80. But for your case, you said like whether we can give the 8080 at the run means and in the Docker file or not. It's actually
Yes.
not suitable and it's actually not advisable to give it because why? See, let me give you an example. First, Docker container RM. First, let me delete this one. Okay. If I just execute this container with 8080, okay. Suppose let me give run hyphen d in detached mode hyphen d detached mode. And if you are saying that instead of giving it here this 8080 port, why should not give in this image?
Yeah, that's what.
In the build. If I
Yeah.
give this 8080 image, suppose I need tomorrow I need another 2 containers. What will happen? Same port you cannot be used, right? Same port cannot be used to create another container. It will throw error because applications can run on one single port only, right? The server can run on single port only. If I just use the same image again and again, it will not allow us to create because it will throw error because the same port is already being used. But if you don't use that one and specify at runtime, what is the benefit? If I just need another container of the same image, right? I can suppose give 82. Okay, the name is same name, so I need to just change it to above 1. I create another container here. Okay, now suppose I need same image to be another container to be created 83. Okay, let's change the name. See, I got three containers of the same image, but it's running on different port. Okay, if you think like if you think I can use the same port again, let's see if I use the same port again, what will it will say? What is it? Error response from demo driver failed connectivity on a endpoint web app 3 bind for this failed port is already allocated. That's why if I just give 8080 and the image itself, we cannot create multiple container. It will say port is already being used or allocated. Okay, so here when I gave runtime, at runtime I created multiple containers. At runtime I created multiple containers. Right? Let's check Docker container. Let's see. We have this web app, web app 1, web app 2. These 3 containers are running. Right? So if I just access these 3 containers with the different ports, 82, 83, 83, right? Before accessing, make sure that 82, 82 and 83, 83 are whitelisted on the Docker server. Okay. Let me log into the Imagine console. There I have to just change the, I have to provide the, I have to whitelist. Okay. Now what I can do, I can quickly go to the instance. I'll quickly go to the instance here. Okay. I'll quickly go to the instance. Let's just a second. It takes some time to get loaded. Okay. Select this one. Let's go to the security. And here you can see I have just whitelisted only 8080 and 8282. But 8383 port is not whitelisted, right? So if I access this Docker, this server and 8080 port, we have one container running, right? And let sorry, 8080 one server is one container is running. Let's create, go ahead here and put 8282 82 82, another container is running, right? Let's go ahead and create another one, 8383 83. So 8383 is not running. See, Docker 8080 is running, 8282 is running, okay, but here this one is not running. Why? It's because this 8383 port is not whitelisted or not firewalled, right? Firewall not access is not provided. So what I can do in this one, I can just provide 8383. I have to whitelist here in inbound, right? Let's go there and go to the security, and this security I have to add the port. Go to the edit inbound rules, and there I have to add new rule, custom TCP, provide 8383, make it public. Okay, now save the rules. Now I saved the rules. If I go here and refresh, see, now 8383 also came. So we have one 8080, 8282, 83. Three containers are running. Three containers are currently running. Okay, in one image I created three containers. If I give a same port in the image itself, can I create multiple containers?
No.
No, right? That's the result we can specify at the runtime. Okay. Now, so Jayshreen was asking like the same image can be used for multiple containers. Yes, as I told, we can create n number of containers from the same image. If it is a web application and you want to connect from the port, then make sure that you change different port while creating the container. As I created it, same port cannot be used. Another way. Now I have one image, right? I have the image, right? Let's do that. This folder, I have the Docker file, and suppose I want to little modify. The developer has modified the code. The developer has suppose modify this particular code, right? And this code, suppose developer has added one index, suppose one image to this file, okay, to this file. Now let's I forgot the syntax adding
IMG source. IMG sh.
IMG and then source something.
Source.
Yeah. So yes. So let's copy this particular thing. Okay. Okay. So I need this particular JP, any image, right? I need suppose okay. I need this image. Suppose I'll download one image here. Let's download any one Docker image. Okay, so let's modify this. I'll just add it docker.png. added one image here. So what I can do here, so Docker image I added. I need this particular file to be copied, right? So what I need then, I have to modify the Dockerfile element, right? Vi Dockerfile, copy docker.png file to this particular directory, right? To this particular directory. Let's then what I can do here. Let's save this file, and in this context area, there should be docker.png file. Now I have downloaded the docker.png in my local desktop. Now let's copy that file to the Docker server. Okay, so how I'll do that? So I have this docker.png file, right? Now what I can do here, I need to copy. So using scp hyphen I just use the certificate file, okay, to copy, and the file name is what is that? Docker.png, right? And I need to copy to situ hyphen user @docker dot colon home, or you can just give colon this one. So what will happen here? I'm just going to copy by using scp command, copy this particular Docker PNG file from my desktop, from my laptop to this Docker server. Okay, to this Docker server. So what is the folder name? I can give as home ec2 hyphen user, and it was given in the web icon. Okay, hit enter. So it is permission denied. Let's put into only home directory. Okay, the file is copied to the home. Why it is denied to copy this? Because this folder actually has only permissions of root user. So as I'm using the normal user, I could not copy. That's why permission denied. Now I change to put it to the EC2 user. So the file has now been copied to EC2 user, right? So if I go back here into this EC2 folder, right? If I just do ls hyphen here, see this docker.png file has come here, right? Now let's copy this using sudo copy this docker.png to web app folder. cd web app folder. Let's check it. See, docker.png here is now. Now what happened here? We have the required files to build our Dockerfile now. Let's see first the images. What we have the images. We have this web app 1.0, right? Now what I just want to do, I create another, because we just modified, right? Added new instructions to the Dockerfile. I just want to rebuild the Dockerfile to create a new image, right? To create a new image. So what I can just use Docker image build, okay? Docker image build, give the tag hyphen t web app 1.2. 1.0 is already exists. I created another image 1.2. This is how you are going to release a new versions of the applications into your container, right? You have to create a new image. Now I created a new image 1.2. So it just copied this Docker PNG file to this one, and also the copy index.html to this. Everything's ready now. If I just do Docker image ls here, we have this web app 1.2 tag, right? We have already 3 containers running. Let me stop 2 containers, right? Docker container ls. So we have this 3 containers running. Let me just delete these 2 containers, 82 and 83 containers. Okay, or let me delete because I just want to use the same 83 port. Suppose I want to use this 8384 port. Let me delete this container. Okay, Docker container rm-f. As the container is running forcefully, I just deleted it. Okay, I deleted the container. Now I want my applications to be deployed with new applications to be deployed to the container. So what I have to use? I have to use Docker container run, right? Hyphen d hyphen name, give web app uh, one, something like this, and give uh, the port 83 colon 80 is the container port, and give the image name. Image name is web app colon 1.2 1.2, right? Let's hit enter. Our container is created now. Okay, now if I go and refresh the 83 port, see, my application has now changed. New deployment. This is the new applications now, and the other others are still using the old image. Are using still the old image. Now, is it very clear, guys, how you have to do this? Any doubt so far, guys?
No.
No.
Cool. So this is how, guys, you have to create multi. Whatever I just told you, right? Everything is the real time. In the real time, how you have to write the images, and if there is any changes done by the development team, you need to rebuild your Dockerfile. You need to rebuild and create a new image. New version of the image will be created, and the deployment will happen from the newer versions of the image. The deployment will happen from the newer versions of the image. Now, let me just give you some examples and different. Okay, now because there are many other commands, right? I cannot go each and everything. So for you, task is to go through this commands and see where the usage of these commands, where to use add, where to use copy, what is this environment command, volumes, user, working directory, we already have discussed, right? Argument and entry point and CMD. These are the few things which I am going to show you now. I'm going to explain, and then you are going to work and do practice. Okay, so what is the
Like for practice purpose, so we can use this, we can edit it and we can use the same image, or we need to give a different version only.
sorry, I couldn't get you. Can you?
So actually, for our practicing purpose, so initially you have created 1.0 and you have added image, and you have built one more image called 2.0. In
One
the
point.
same 1.0 itself, can we edit and build it again?
Then that is the no point of creating this, and see if you need something. Suppose you need to roll back, you need to get the previous version. Then how will get it?
Okay, it's just for practicing purpose I asked actually.
No, you
So,
can never do that, because even though you do practice, create new image, new version. That is the best practice.
okay,
Always
okay,
create new tag. Okay, that is what, because if you don't do, if you do practice of deleting the previous version, then that practice will make you. Then in the real time, if you do same thing, then it will impact your work, right? So never do.
yeah, okay.
Yeah. So always do.
And one more thing is like in Jenkins, so we used SEM, right? Poll SEM and source code continuously it will poll like that. So here, so we need to once we have the new code and something like that, so we manually need to build it.
Yes, we need to manually build it. And the same thing, see, manually, so only one command you have to use to build it, right? It's not manually. Even though in Jenkins, we can integrate Docker in Jenkins to build it. So Jenkins also will build it for you. You don't have to again manually build it. So here what happens, I showed you to manually execute the command, execute this Docker build command to manually build it, right? Sometimes what happens, not sometimes, and in your company when you do automations, right, you can integrate the Docker with Jenkins, so that Jenkins will automatically pull HTML, GitHub hook will trigger that, and automatically the Docker image will be created for you. Then you have to create container, do the deployment. Okay, that will see, that
Okay.
is the project what we have to do it after the completions of Docker, and we'll do this project in Jenkins. Okay, don't worry.
Okay.
Yeah. So what is that? So we got it. Now let me just explain few things. to cover it. Okay, there are few useful commands, Dockerfile commands, and which I believe is useful for you. The copy versus add, right? We use the copy command, but we have not used the add command. When to use copy and when to use add? If you just see this here, we have the add command also, right? Add, add. See, add commands. When to use these add commands? Let's see the differences. You may get questions on this. Okay. So what is the difference? Copy and add are both Dockerfile instructions that serve the similar purpose. They let you copy files from a specific location into the Docker image. So from a specific image to the specific locations into the Docker image. Copy text in a source and destination. It only lets you copy in a local file or a directory from a host or the host building the Docker image into the Docker image itself. That means using copy, you can locally copy from the path, from the context, or from a specific location locally to the container or to the image. But add, what happens? See, this is what we used, right? We already used this command, copy index file, all this. But add lets you do that also, but it also supports two other sources. Add can do copy locally. Also, it can copy from a server. Suppose you have an image file or you have a file in a different server. If you want to copy from that server to your image, then you can use add command, not copy command. Copy only can be copied from locally to the destination server, to the destination image. But add can give you from different source machine, different source server to the container folder or to the image. Similarly, if you want to copy a zip file, what it do? You can use add this gz file. What it do? It will add this file, and while adding, it will extract also. This is a compressed file, tar.tar file. When I copy using add command, it will untar this on this folder. The archive file also can be downloaded and extracted in run command. So instead of using this, you go with run command. So what this run command does? Let me explain you the run command. The run. So the run instructions will execute any command in a new layer on top of current image. If you want to execute any cell command, if you want to execute any installations, if you want to do any installations, you can go with run command. Okay, you can go with run command. Let me show you this run command example. I have in my GitHub repository. You can just go there also. In my GitHub repository, I have few things. I had recently created one YouTube video for that, and I have kept everything in this GitHub repository as public, so you can go with. Okay, so in this Dockerfile DevOps tool, right? Dockerfile DevOps tool, I have created 3 Docker files for different tools. For Ansible, for Git, for Terraform, I have created. Let me show you for the Dockerfile Git. Here I have written, see, small. I have written small Docker file where being run command used. So the run command used to install some Git, see, apt-get install Git, install Vim editor. You can use run command to install something. Same thing is being given it here, right? So the run command is given to install or execute some commands. Okay, now, okay, let me explain further here. So you can, using run command, you can download this particular file, and using run command again, you can use tar command to extract this file on this particular folder, right? So which is good. Here in this case, you have to execute 2 commands. But if you use add, what it will do, it will just get this file and extract into this folder. That's all. So that is the benefit of using copy versus add. That is the differentiations. Okay, and this is the benefit of using add command. Now let's see other few more commands. Entry point and CMD. This is a very good good command, and you'll get lots of maybe questions on this. What is the most important and differences between entry point and CMD? So the entry point and CMD. We saw the example of the CMD, right? To execute the shell script, right? I just wrote a BGBox image, and there I had written to execute, right? CMD, SH, and shell script, right? Here, why then we have to go with entry point? See, entry point to CMD when building executable Docker image, and you need to command always to be executed. Prefer entry point. So remember this line. You should go with entry point when you want the Docker image and you need the command to be always executed. Then you should go with entry point. Additionally, use CMD if you need to provide extra default arguments that could be overwritten from command line. Remember, if you are using entry point, then CMD command must be used. If you're not using entry point, then you may or may not use CMD. That's not mandatory. But if you're using entry point, then CMD is must, right? So how you used CMD? You can use CMD echo here. And if you do that, create one CMD echo here. If I just create image name and execute in the bin bash, then it will just execute it. So when the container create the extra command in the runtime, it will be overwritten. This one. Now the difference is entry point command and parameter are not ignored when Docker containers run with command line parameter. So here we use CMD echo hello Docker, right? Let me give you an example here. Let me give you an example here. Let me create one Docker file. And here, base image suppose from BGBox, CMD. Okay, CMD. What is this? I'll just write the command called echo hello Docker. Save it. Let's build the image Docker image build -t demo colon 1.0. Right? We got demo 1.0 image. We got demo 1.0 image. Let's create container. Let's see what is happening. Docker run -it demo 1.0, right? Demo 1.0. Hit enter. So what it says hello Docker. This particular image gives us hello Docker. This is the only things which was given in the instructions of this image, right? Hello Docker. So if I just pass another command here, right? I'll just give us suppose Ranjit. Sorry, it will not work. Suppose I give, I should give an executable here. Suppose I'll give bin bash. Well, run created unable to start container process bin bash. That's no such file or directory or node. Okay, so it's not running by providing this -it options and bin bash. Okay, if I just do pwd, okay, it's not working. But the same things, if I use the entry point, right? Now let's go to the entry point. In this same Docker file, instead of adding CMD, let me just use entry point here, entry point. Okay. Now what I have to do? Let's use this complete copy paste there. It saves some time. But I used one command bin echo hello DevOps. Right. Let's save this one. Let's build to a new image 1.1. Okay. Same image you can 1.0 also you can do, not a problem. Okay. It will overwritten, but better to give a new tag. So we got a new image 1.1. Now let's build with this 1.1. So what it gives? Hello DevOps. Now if I just want to, let's modify this image here again. What I do here, I echo here emd. Let's build 1.2. Done. Let's execute the command 1.2. So what it gives? Only Docker here. Only Docker. What will happen here? What happened here? The entry point. Okay. So entry point. Suppose let's give DevOps. So let's rebuild. So what is give? What it is giving, guys? It gives DevOps and Docker. It both gives DevOps and Docker. So if I just open the Docker file, what happens here? It first printing DevOps and then giving Docker, right? So what will happen here? Let's go back and use our two image. Two image is only giving Docker, right? So if I use here DevOps, see, it gives DevOps. If I use anything here, it gives. So what is this actually? Why it is behaving like this? What happened here? This entry point, if you are providing this entry point, if you don't provide anything here, that's okay. If you don't provide anything here, with this entry point, with this command, we are executing this particular Docker, giving echo Docker. If you want to override this, if you want to override this in the runtime, then you have to use this entry point. You have to use this entry point. Instead of Docker, if you want to override DevOps, it gives us DevOps. If you override Ranchi, then it gives us Ranchi, right? Now, let's give you another example. Let's show you another examples. I'll just show you, then you have to do the practice, okay? Okay, same examples, but let me just edit it. Instead of this, I can just give you ping. And here, suppose I'll give you google.com. So what will do, this command from VGBox, it will ping this google.com server. It will ping this google.com server, right? Now let's hit enter. Now build another image, right? Build another image 0.4 suppose. Oh, sorry. It's not, I need to use build, right? Build 1.4. Done. 1.4. See what happened? Our container is pinging now, right? Our container is pinging google.com. Container is pinging google.com. Let me come out here. Now, suppose you want to ping something else. By default, it is pinging google.com because we have pressed or we have given the command google.com. If you want to change it to something else, suppose I want to ping ranjitswamy.com server. ranjitswamy.com server, right? What will happen? See, it is pinging ranjitswamy.com. anything you want to override the command during the runtime, then you have to go with this entry point. That is what I just want to show you. Now, the entry point specifies the command that will always be executed when the container starts. The entry and CMD specifies the argument that will be fed to the entry point. So, if you want to fed to the entry point, then you have to go with the entry point CMD combination. If you want to make an image dedicated to a specific command, you will use entry point. Okay, that is what being used. Now, another good example, another good differentiations is between the ARG versus environment. ARG means argument. How will create argument in the Docker image, in the container, right? So if I go to this Docker file, you'll find this arg and env environment, this environment variable. The env instruction sets the environment variable in the Docker file, and arg is the provide the argument. Arg is the provide different variables that user can pass build time. The build time. Okay, let's see the difference here. There may come a time where you may want to add an environment variable to your Docker image, but you will want this value to be different depending on where you build your images, but you don't want to edit your Docker file. Suppose whatever you have given to in a Docker file, you don't want to edit it. Sometimes if you have created the environment variable and don't want to edit it in the Docker file, but during the runtime you want to change it. So you can do that by using the, suppose here I have written small argument, your application environment is productions, and created one environment variable, and here I have given the argument as your app environment. This is the argument. Okay, your app underscore environment, and here your app underscore environment is given as the productions. Now if you run this during the runtime, it first gives us productions. If you want to change these productions and run into a staging environment, then during the build time, without changing the code, during the build time, you can specify with this particular build arg, and you have to provide the argument as staging. Then it will change the image without changing the Docker file. Without changing the Docker file. Let me just copy this part and just ping you and keep it handy and do practice. This is a task for you. I'll just move on to the different next topic. So this is a task for you. I just ping you this related to particular build environment and argument, and you do practice. Okay, today.
So this is similar to the entry point, right?
Exactly. It's that has different roles, but similar to this entry point. That's totally different. Okay.
Okay.
Yeah. Now, that is another very important thing. So I'm going to discuss with you is the Docker ignore. So what is this Docker ignore, Dosh? This Docker ignore actually, before the Docker CLI sends the context to the Docker daemon, it looks for a file named Docker ignore. Okay. So whatever we have kept in this context file, PWD, this is the context. Suppose let me go to the web app. What is this? Oh, it's in the web. CD home feature. Not user, C2 user. Hyphen user web app. What happened? Now, if I just go here, we have this in context file, we have lots of files there. When you should go with Docker ignore, and why Docker ignore dot in Unix or Linux, dot is treated as a hidden file, If you don't want any context, any file or anything in the context to be copied during the build time into the image, you can specify those things in the docker.ignore file. Okay, so what kind of file you don't want to build? The sensitive informations, the credentials, the password, those things you don't want to copy to the image file. Okay, so that you can, or anything which you don't want some extra file generated during the build you don't want to copy, then you can ensure in the Docker ignore. Okay, suppose how you'll create it in this context file, you will create vi suppose dot docker ignore. This is how you have to write dot docker ignore. Hit enter. Suppose I don't want start dot cnf or db dot config something. These two files, or the files which are ending with .cnf, and the file name is db.cnf, db c1f like config. Sorry, db config. I don't want this file to be copied. I don't want this file to be copied. Right. So what you can do, you can just add it, and while during the build, these particular two files will not be copied. That is the usage of the Docker ignore. That is what is equal. If this file exists, the CLI modifies the context to exclude files and directories that match patterns in it. This helps to avoid unnecessarily sending large and sensitive files and directories to the daemon and potentially adding them to image using add or copy. This is what you have to use it. Okay, guys. So that's all for today's class. So now next class we'll have the Docker Compose discussion, how we can create multi containers and how we can manage them. Also, we'll do a project in our next class on next Saturday. Then we'll finish this off next Saturday. Okay. Okay, guys. So in our last class, we had already completed all the things on the commands and all the details about the Docker, how we use the Docker commands, and how we saw how we can deploy applications using Dockers and all. So in this class, we'll talk about more advanced things like the volumes, how we can persist the container data, and how we can see the CPU memory usage, how we can just go with the networking part, right? We'll see how the Docker networks works. Also, we'll see how after creating the images, how we can push into the registry. So all these things today in this class we'll see. Along with, we'll go with multi-container things like using the DockerCompose. Okay, so let's start. I think the volume, you guys might have heard about this volumes, how we can store the data and all. So why the thing is why we need the volumes, right? So in this class, I'll discuss about the real-time scenario and when you should go and when you should use for volume. Why should you use for volume? First thing, why? Let's see what is the volume and how we can set up this volume to persist or save the container data. Okay, so the volumes, right? The name itself, you might have used it many times in your day-to-day life, right? So here in the Docker, we are going to store the container data in a server or in locally in your laptop or anywhere where you are running the Docker. So why we should save the container? So the nature of the container is when you create a container and you don't create the volume and don't save the data, what happens when a container is dead or a container is exited? What will happen? The data generated by the container will also be erased. Okay, will also be deleted. So sometimes what happens, you need because your critical applications or some applications are running, and you sometimes what you need those data to be there to troubleshoot something, or you need those data to be there for future reference. If your container is exited or deleted, your container all data will be lost, right? So what do you have to do? You can store this data locally in your system or in a server by using the Docker volume. Okay, so the question in the real-time scenario, the question may come how you can store the container data, or if you don't store the container data, what will happen, right? That's called storing the data or persisting the container data. Okay, That's called data persistence in Docker. So there are a few commands that are not much too theoretical to discuss, but let's talk about. There are a few commands. Let me log into the Docker server first. Then we'll just discuss about this one. Okay. SSH protocol. Sorry.
SSHI.
Okay. Good. So I connected to the Docker server. Now, if I just do Docker help, right? So we have the volume management command. See, we have the manage volume command. So if I just check here, if I have any volume available or not, right? Docker volume ls. So we have, there are two volumes available. From one of my previous project, I have created few volumes here, right? Now, how we'll create the volume and how you can store the data, right? So before moving that, let me show you a few commands and then explain you, then we'll do the demo, right? So here, there are very easiest way to create is Docker volume create and the volume name. Okay, Docker volume create and volume name and list ls. And if you were to inspect you in our last class, I was showing you, right, how and why you need to inspect, right? If you need to see the details about the volume and where the volume path is mounted, right? Last class I showed you with this volume particular WordPress dot underscore db, right? So if I just do Docker volume inspect, right? Now give the volume name. So here what happens, it gives the complete details about the volume, when it was created, what is the driver being used, the labels, right? And the mount point. So this is the mount point where the data will be persisted, where the data will be stored, right? All the data will be stored under this particular mount path. Now we need to just get this path and go there and your data will be stored. See here, this particular WordPress underscore database TV, right? The volume name and the, if you see here, if I do container ls-a, there are lots of things being running. Okay, there are lots of things are being running and exited and see, it might be the okay. See here, the WordPress thing is now no more there, right? But still, I can get the data. The container is no more there, right? It's deleted. But the data, as long as the volume is available, right? The data will be there. See, if I go to this particular path, see, all these data for this WordPress is available. If you want this particular volume to be, particular data to be reused by the container, then you can map the container to this particular volume. Then all the container will also have the same data. So once we'll do the demo, I'll show you exactly how it works. Okay. Now, what we can do here again. Okay, let's see here. So how you'll just add the volume? It's very simple by using the -v volume name colon and the container directory and the container directory. There are few more documentations are there. I'll just go with the document, but before that, let me just go with this all the details how I could, how we can create and manage it. Okay, so let's quickly go ahead and see some example here. Okay, if I just go to the home directory of the root, not user, EC2 user, right? Sorry, it's home EC2 user, right? Home EC2 user. Okay. So we have one Viva folder, right? There we had created the image. Here we had created the image, and we have this index.html file, right? And we have this all details available. And with this Viva folder also, if we just check this image we had created, if I do image ls, we have this wave of 1.2, right? Wave of 1.2. So this image was created, right? If I just create a container, okay, guys, can you tell me? I have suppose these many containers are there. I don't need this container, right? I don't need this container. So how can I just remove this container? See, there are a few exited and few are still running, right? 5 days still up for 5 days. 5 days is still running this application, right? How can I just delete this? Can you quickly tell me, please?
We are using the command docker container rm the container id. That is the one thing, and the second thing is which are up and running. Then we can use docker container uh, docker container rm hyphen f. Then the
Okay.
container
So
id.
okay, cool. So let me just use it. Okay, Docker container rm hyphen f, right? Pass the into the source. I need the ID, right? So
Yes,
the ID, so we have to get a Docker container
container
hyphen
ls
q.
yes.
Okay. So this is how we have to delete all the content. So it's deleted everything. Let's check Docker. Okay. Will it would have been deleted everything, guys? So it's deleted only 3. Which 3 it is deleted?
Mm.
There were many containers, right? But it deleted only 3. It's because I gave only to delete the running container, right? But I did not specify hyphen a here. Okay. So to
Okay.
delete all, so you have to specify a.
Okay.
Right? See, it deleted all the container.
Yes.
All the container. Okay, this is how you have to do it. Don't worry, it's a very simple thing. Now, all my containers are deleted, right? But I have few
Yes.
images are available. So let's do something here. First, let's create a volume, right? Suppose I'll do Docker volume create, okay, and I can just give as demo volume. Suppose demo volume, demo volume, right? Volume is created. Now what I need to create a container and attach the volume to there, right? So to that, I can use the image, available image. Okay, I can use the available image here to do that. Suppose my image, I'm going to use this web of 1.2, right? So what I can do here, Docker container run hyphen t, okay, give a name, hyphen p publish, right? Suppose 8282 colon 80, right? And the give the image name, that is wave colon 1.2. So what it will do, it will create a container and persist all the data, right? Persist all the data. Now I need to persist all the data, but this command will not persist anything because it's simply without allocating the volume, without assigning the volume, we are just going to create, right? To assign the volume, what you have to do, you have to simply write signal hyphen v and give the volume. So what is the volume name? Our volume name is demo vol, right? Demo vol. Then this is the volume. Now I need to mount this volume to a path inside the container. This demo volume is available on the Docker server side, right? And a colon, and then I have to provide the container path. Which path I need to map or mount. Now, what I have to do, suppose I want to mount it user local Apache 2 colon htdocs. This is the directory where root directory or the working directory where used to put the index.html, right? The web applications, the web server will take it, the index file here, and it will run, right? Now hit enter. So it just created a container. And if I just check our container, see, container is running. Now let's go ahead here, 82, 82, right? 82, 82. So it's running now, right? Now our volume, if I just go ahead, right? If I just go ahead and check the volume, let's go ahead. If I just do Docker volume ls, our volume is created. Now if you just want to check the path where it is mounted, just do Docker volume inspect and volume name. So here is the path. If I just go to this particular path here, we can see this index.html and docker.png file has been kept and the data has been stored here. And these are the container data. These are the container data, right? So if I just go inside a container and put something into that particular container path, suppose if I just go to, so what is the command, guys? Can anybody tell to go inside a running container?
Docker container execute ex yes.
Okay, cool. Thank you. So exit, then you have to provide the container ID or container name. So in my case, I don't remember the ID. So I give my app here, and then you have to just give suppose win bus here, right? Hit enter. So I went inside the container and I landed into the working directory here, right? So if I just go to htdocs here, see, you can see here we have two files in the container inside this container directory, right? Inside this container we have these two files, right? Now if I just go ahead and create one more file over here, let's test.txt file, right? So now three files been created here in the container. Inside container I created one more file which is test.txt. If I come out from this container and go to the volume path, if I do ls-l here, see the test.txt also been copied or been kept it here, right? As this container data we have mounted with our volume, everything you put it in your data, container data, and the same things if you put in there also, everything will be synced. Everything will be auto synced. Now if you just if you want to change something, your data, you don't need exactly to go inside your container. Instead, what you can do, you can put it here itself in your mounted path. This will reflect directly to the container path, right? Now if I just do some changes, let's do some changes to this file. So what I can do here, I no need to go inside the container, do some changes, ad hoc changes. Remember, guys, this is some kind of ad hoc changes. If you want to do it some things to get it quickly, you can go ahead and do that. But normally we don't do some changes directly into the container. So in the real time, how it works? Can anybody tell? If you understand clearly the concept of the Docker deployment, how the Docker being used, how you have to work, can anybody tell? Let me tell you the requirement again. The requirement is I need to change something into my applications in the index.html file, right? So either I can go inside the container and edit it, or directly I can edit into this path itself, or it will reflect there also, right? So the requirement is I need to edit something in the index.html file. What is the best way? What is the right way to do it? Not best way. What is the right way to do the changes to the release or to the
I think we'll go to the inside the container and change index.html.
okay. So anyone else? Dhanidhar, Alvin, anything else I need to do? Okay,
So do you need to test it in the test environment like that?
no. See, just see the real time how it works. As I said before, any changes to the applications you need to deploy, you need to change the code and you need to write the Docker file again, right? You have to rebuild the image. You have to rebuild the image. That's why I was showing you in your previous classes, right? You have to rebuild, you have to change something. Any modifications required, you have to change in the Docker file if it is required, and you have to rebuild it to create that new versions of the image. And that new versions of the image, you have to create the container. That is the right way to do it in the if you are working in your company or organization. You never go to the container and do the changes for your applications. Why? Because
Okay.
if the container is exited, right?
Yes.
All the data will not be taken, right? Though you kept in persisted data, but there is no guarantee that if the data itself the storage is deleted, somebody is deleted, will not have anything to be there to get it, right? That's a risky. You should not do this. But ad hoc basis, if you need some informations to be there to create it and do, you can just go to the container and do that. But never do any changes to the applications directly into the container. That's the real time you have to do. Okay. Now for the demo, let me show you how it is gets reflected there. If I'm into this uh, volume, right? I'm into this volume. Now, if I just do some modifications to this index.html file, this is hello Docker, and I'll just put one more tag here. Suppose that's true, and I just put volume demo, something like this, right? I put it there. So I saved it, right? Where I saved in the server, not inside the container. In the either you can log into the container and there you can change it, or you can directly change into the volume path where the container path is mounted, right? If I go here and just refresh this, see, I did not went inside the container. Simply I modified to my things here itself, right? Now, what I can do here, I'll ask two questions here. If you remember, if you understand properly, just tell me, okay? Now what I can do, let's delete the container. Let's delete the container. So I deleted the container. If I just go ahead and refresh it, okay? I'm just going to execute two commands and then I'll ask questions. You have to tell me, okay? And just watch carefully and just see what I'm doing it first, okay? Let me create two containers first. Docker container, okay? Run type in name. I'll give it is my let's give it my type in P8282 colon 80 and wave half colon 1.2. This is one container I'm going to create without mapping the volume, without assigning the volume here, right? Without assigning the volume. Let's hit enter. So one container is created. port 8282, right? Let's create another container from the same image, another container from the same image, right? I used web of 1.2, the image, the same image, but to the different port 83 here. And this time, let's map the volume. Okay, what is this? Demo vol colon path, right? Sorry, that's user local, then Apache 2 st docs. Perfect. Hit enter. Sorry, the same name is already exists, so we need to change the name also, right? So the name, let me give it as my app 1. So we got another container. We got another container. So we have now two containers. We have now two containers running. See, 82, 82, 83, 83. Now, if I just go and refresh this 82, 82, what will happen? See, now the 82, 82 is not assigned to a volume, right?
Yes, yes.
What happened? It directly created the applications out of the image what we had created from 1.2 tag. If I just do here 83, 83,
Then it will assign the volume.
see, it has the volume table. See, two containers, same image, one assigned to a volume, another assigned, one assigned to the existing volume. So we had exited, deleted the container, but the data was persisted. The data was persisted. So the data can be used to recreate the container. So now we don't lose our data, right? This is the beauty of the volume, and you need to use it. So this persistent volume, again, we'll learn in our Kubernetes class in detail. We have multiple, we have bigger classes in that way. And we have these documentations. If you want to go to learn more on that, I would suggest you just go to this storage, and let me ping you also. So manage data in Docker, okay, volumes, and how we have to do everything up there in details. Okay, there are lots of things, but as you understand how we have to use it, go through that. The same things what I explained, everything will be there, how it is there. Now, if I just go you and give all the details about these volumes, do practice, and how you have to use volume flag, right? The signal you have to use -d, or you can use --volume, right? Now let me just ping you this particular thing. So storage. Got it? Let's go ahead. Now, so the volume part is over. Now, let's quickly move into the CPU and memory usage. I think I already have shown you as very simple commands you have to use. Docker stats. I already have used these things, right? I don't want to tell you again. And also, so if you want to limit the usage of the CPU, someone was asking in my previous first classes of the Docker, right? How we can just specify the CPUs. So you can use hyphen CPUs equal to -5. So that CPU is this much CPU and this much memory. If you want to specify the memory also, so beyond this 100 MB, it will not use it. Okay, so you have to specify hyphen memory, and then you can use it. Right, and the Tom container, it will give the process details, what are the process, and here it will give you the statistics, CPU and memory uses, Docker stats, and the container ID. Right, so if I just go ahead and if I just use Docker stats, either container ID or the application name. Okay, suppose I give the container ID here, it will give the statistics, right? The CPU usage, memory, how much memory is being used. So this is a very simple single, let me come out from here. It's a very simple index.html, right? One HTML file. That's why it's not consuming the CPU at all. Also, it's very less memory being consumed. Your applications could be a Java applications, your applications could be a .NET applications, could be Python applications, could be AI artificial intelligence applications, could be anything. It could be used, right? The memory can be used 1 GB, 2 GB, or 5 GB of memory, they will take it, right? So based on that, you have to specify the memory. Based on that, you have to specify the CPU usage. 50% of CPU if you need, or 20% of CPU if you need. All these details you have to provide it. Okay, that's the simplest way to use. Now let's move on to use the images and to use the registry to push the images that one. Okay, now what we'll do, working with image and registry. So in our classes, we already have seen that to build our own image, the same things I have written here, right? The same things being written. But after creating the image, you might need this image to be put into a
Docker Hub.
house, right? Need to put into a Docker house. So I just logged in here. You can see here I have few images are available here. Ranjit, my demo of and all these things are available here. Now Ansible, Terraform, all these images I have created. Now let's do here whatever the images we have created, right? Whatever the images we have created. You know how to create the image, right? I'm not going to explain those images again, how to build the image, right? From the Docker file. Suppose I need this particular image to be pushed to my
Docker Hub.
Docker house, right? So what I'll do here, for that, you need to first log in. You need to first log into the Docker hub. To log in that, you can use Docker login and the username, right? And then you have to provide the password. So what I can do, I can use Docker login hyphen username equal to, suppose in my case it is Ranjit, right? Login. So it will ask for the password. Give the password. It will give. If it is succeeded, yeah, login is succeeded, right? Now let's clear it out. Now I logged in to the registry. What I can do now, we can just push it. To push this one, it's very simple. Use docker push command, then repository name and the image name. Okay, so our image, let's take it again. These are the image. Suppose I want to push this image, right? What I'll do here, use docker push, then registry name. My registry name is Ranjit Swain, right? Slash web app, right? Web app, then colon 1.0, suppose. Hit enter. So what happened here? Says the push reference refers to the repository. Yes, correct. But an image does not exist locally with tag Ranjit Swain. Yes. So before pushing this one, your repository name should be like this. Okay. To do that, what we can do, we have to just tag it to Docker image tag tag, right? Then what you have to do to tag? Which one you have to tag? You have to tag web app 1.0 to the registry name, right? So my registry name is Ranjit Swain slash web app colon 1.0. First tag it. Now I tagged it, right? If I just check Docker image ls, see this is now tagged. Now we can execute the push command. Now we can execute this push command to push to the registry. Hit enter. See, it's now pushing. So before pushing it, make sure that your tag or repository name, whatever you are giving, you have this registry name or repository name added to the image. Now it is pushed, right? If I go here, we had these things, right? My demo of Terraform, Ansible, and Git. If I just refresh this one, we'll get another image uploaded or pushed here, right? See, this web app few seconds ago we added it. Now if I just go ahead and click it, we have this 1.0 tag. We have this 1.0 tag, and it says how we can use this one. Also, in your laptop, right? If you use Docker, okay, if you use Docker pull command, right? Suppose if I just click on this web app, let's go back here. Okay, just go to web app. If I just let's public view. See how we can use. You can use run Docker pull Ranjit Swai web app. So suppose if you use it, you can create a container from this image also in your site, right? Now let's go back. We have 1.0. Suppose I want to push another tag. What I can do? You can just use first tag it, right? I want to suppose this 1.2 version also I want to upload it, right? So what I can do first, tag this 1.2 with the repository name and image name, hit enter, and then you can just push it 1.2. This you can push it, right? Hit enter, just push it. Done, right? Now what happened if I just go ahead and refresh it? See, we have this 1.2 also. Few seconds ago, 1.2. If I just if you want to use this 1.2, you can just use Docker. Let me just do that. Okay. What I can do, if I want to create a container from that, just use Docker run, right? I can choose, I can name my two, suppose, and then what I can do, just publish it. Type in 8080 colon 8 image. So what will happen here? First, it will locally check in your laptop. If it does not exist, then pull out from my registry. Pull out from my registry. So which one is my registry? This Ranjit Swang is the my registry one, right? Now hit enter. So it found locally because it is locally also available, right? If not, then it will pull out from locally and create it. Now the container is created. So if I just use here Docker dot Ranjit Swang and 8080, right? See, we have this things created. Okay, now this is how you have to use it, right? 1 second, guys, I'm getting a call. So guys, this is how you have to use and log in and push the images. After, build your own image and you can store it on your Docker private account. If you want to make it private also, you can store it as private. Now what happens here, in my account or in my repository, we have these web app applications, web app image available. This is how in your organizations you might have different registry, different repository systems where you can store your images. Few people may be using ECR, Elastic Container Registry, right? that is Amazon Elastic Container Registry that you can use to store the data, or you can use your own server where you can store your data also, right? This is how you have to work. Any doubt, guys, so far? No? Now let's move on to the network, right? So this networking part is most important to understand actually how it is working. For that, there's a very good documentations being created by this officially Docker page, right? docs.docker.com. So this is a network overview. Remember, by default, when you create, you'll have the bridge network, right? Let me first go here. If I just do Docker, just use Docker, right? What I can do here, if I just do health, right? We have this network management command also. See, manage networks. Now, if I just do Docker network ls, see, it gives default bridge network will be there. This is the default network. Bridge network is the default network. Then host, then none, right? Let's explain more on this bridge network. So why we need a network first? Why we need a network? See, in a simple term, if you understand, if you construct a house in a land, if you purchase a land and construct a house, you need a path to go to your house, right? You need the address, you need the path to go to the house, right? Similarly, if you have created the containers, we need a network, need a path, how we can connect to the container. So this bridge network, the default network, which is being created by default by the Docker engine in order to communicate with the containers. So if you want to see more detailed about this network, you can just use the command docker network, network inspect, okay, and the network name. So the network name is, either you can give the network name or network ID. So bridge, sorry, it's a typo here. See, it gives complete details about the network, bridge ID, when it was created, type of network, scope, driver, okay, what is the subnet, the IP address, the subnet, right? All this being used here. So this is the subnet, CIDR range, and what is the IPv4 address, everything. Everything is being added here. Everything is added. So this is how you have to use. To know more about this Docker network commands, as I said before, you can just use Docker network help, right? You see, these are the commands which you can use it with networks. Connect, create, disconnect, inspect. Ls. Connect is to connect a container to a network. So you might get questions how you can connect a network container to a network. Suppose you have, see, if you create by default a default container, if you create by default, what will happen? It will connect to the bridge network. Remember this question, you may get it. By default, a container connects to the bridge network. If you want to connect to your inbuilt network, what you have to do? You have to create the network and connect it to the container. Okay. So to create a network, you can use the create command. You can use the create command. Okay. So it's a very simple ways. I just showed you how you can use it. But before that, let me explain you more about the networks. Okay. So the scope, let's go network drivers. So these are the drivers, bridge drivers of these networks. This is the default network driver. This is the default network driver. If you don't specify a driver, as I said just before, this is the type of network you are creating. This is the default network. These networks are usually used when your application run in standalone containers that need to communicate, right? Standalone container. That container is not interacting with another container and is not related to any specific network. If you just create a container, standalone container, it will by default it will be used by bridge network. Okay. So next is the host. We just saw, right? Host is the, again, it is for standalone containers and remove network isolation between the container and Docker host. We have this overlay network. This is the very important one, guys. This is for demo purposes. Everything is being used under bridge network. That's fine. But this overlay network is just no need to go for this. Okay, host overlay network is overlay networks connect multiple Docker daemons together and enables a swarm services to communicate with each other. If you manage multiple containers, if you managing multiple containers, right? That means that times you have to go with overlay network to communicate with each other, right? Suppose you have 3 containers, right? And one container is having your UI, another container is web logics out there, another container, suppose database container. To that particular stack, if you want to create it, you need to connect each other, right? That time you can use this overlay network to connect. Okay. So that is we are going to learn in our Kubernetes classes. Okay, the networking stuff we'll learn in Kubernetes classes. And we have this IPv LAN, MACV LAN known for this container disable all networking. If you don't want the container to be accessed and all, you can disable it. Usually used in conjunction with a custom network driver. None is not available for some services, network plugins and all. So these are things is not equal. You just go through this particular documentations and just try to find out and elaborate and get more details about the networking. Okay, so all these networking stuffs we are going to learn in the Kubernetes class. Okay, so that's all, guys, for Docker so far, and let's move on to learn Docker Compose. And in our last class we discussed about Docker Ignore also, right? What is the Docker Ignore? I also gave you the example. What is Docker Ignore? We have discussed about the Dockerfile and everything, right? Now, the Docker Compose. So far, whatever we have covered, right? So far, whatever we have covered, the standalone single containers we are working. The standalone single containers we are working. But the Docker Compose, why we need Docker Compose? First things, why we need Docker Compose. So Docker Compose is required to create and manage multiple containers. At the same time, if you want to create multi-container stack, you can go with Docker Compose. That's for multi-container stack. But container management, container orchestration is totally different. That we can achieve using Docker Swarm or Kubernetes. So we are going to learn Kubernetes, which is most powerful and demanded tool for continuous deployment. Okay. So, okay, that maybe take another 31 hour of classes. Actually, I'm not feeling it well today. So what we can do, we can stop the classes now and we can continue tomorrow. Okay. The Docker Compose I'll cover tomorrow. And from next classes, I think we will go with the Kubernetes, right? Okay, guys. So let's start with Docker Compose in today's class. So in our previous classes, we have already completed the entire Docker things, and we saw how we can create our standalone Docker containers and how to deploy the applications into it, right? With various options, various use cases, everything we have already covered. So today's class will discuss about the Docker Compose. Okay. So Docker Compose, as I said, we have learned the standalone container, the single containers working so far by creating, executing the commands and create containers one. But here with the Docker Compose, and it's actually a Docker Compose tool of Docker, using we can create multi-containers. Okay, so before moving into and do the installations and do the the commands and work and the projects, let's understand what is the Docker Compose and what are the benefits we'll get out of that. Okay, so if you just follow their Docker Compose documentations, right? Docker Compose documentations, you can see here they have given lots of definitions they have explained over here with all the guides they have, right? So what they say actually, a Compose is a tool for defining and running multi-container Docker applications. This is the single line statement. You can just say Compose is a tool for defining and running multi-container Docker applications, right? So when I say like we can create multiple containers using Docker also, right? Why should we go for Docker container? Sorry, Docker Compose. So with Docker Compose, we can, using a single YAML file, within a single command, we can create and start all the services from the configurations whatever we have written. So unlike Docker, it also creates the containers. But the thing is, the containers, whatever we are going to create and manage, everything you are going to write in one YAML file, right? In YAML file, the syntax you have to go to write it, and in one single command, you can execute this and manage the entire Docker containers. So we can start, stop, and rebuild the services, the status, everything we can check it. Okay, so here it has the installations of the Compose. I'll show you how you can do that. Like, let's see the key features and the use cases. Where should you go for here? So here the key feature of Docker have multiple isolated environments on single hosts. Remember, it's not like an orchestration. It's not like we can cannot run this Docker Compose applications on multiple hosts or multiple nodes. It is a single host we can execute this multi-container using the Docker Compose tool. Okay, so Compose uses a project name isolated environments from each other. We can make use of this project name in several different contexts. So we can create dev hosts and CI server, all these things, right? Have multiple isolated environments. So it also automatically preserves the volume data. So in our last class, what we saw about the volume, whenever you want to create a container, we have to allocate, or we have to assign the volume to the allocated to the volume with the container path, so that we can preserve that particular path with the volume. But here in Docker Compose, you have to just specify in the YAML file. In that file, it will automatically get the volume created and the data will be preserved. Okay, the data will be preserved. So these are the things and common use cases as anything development environment, automated testing environment, single host deployment. So what it says is actually traditionally it uses for single host deployments. Compose has traditionally been focused on development and testing workflows, but with each release, they are just upgrading it. So as I said, all the tools whatever you are using, always follow their document. If you the documentations has everything, right? And they keep upgrading their server or their services, their tools, the technology, whatever you are using. You follow their official documentation page. They keep upgrading and updating everything all the time. Okay, so you'll get up to date knowledge on that. That's okay. So let's move on and see how we can install Docker Compose, right? So if I go to the overview, and here you can see here install Docker Compose, right? Click on this. So you'll be landing into this, and we have different ways of installing Docker. Suppose if I go for Linux environment, it has the platform Ubuntu, Debian, or Fedora. Whatever things you want, you can just select it over here. Suppose if you go with Ubuntu and it has these details command, you can just go ahead and install it. Okay, and also I have other ways to install Docker Compose. We can simply download the executables, and then using that we can run it. Okay, so the installations is very easy, guys. So it will be not much hectic and all. So here in the two ways you can install it. The first way I have just mentioned it here, just to download the particular versions of the Docker Compose, and then we just make this file, because this Docker Compose is an executable file. We have to just download it and make executable and just run this one. Okay, or you can directly using this pip install, the pip package manager, using the pip Python package manager, you can just install the Docker Compose directly. Let me ping you these installations and it will be very easy. I'm not going to show you, but let me just go through that and I'll just give you how it looks like. Okay, if I just let me just ping you this. Yeah, so this is the installations of Docker Compose. Keep it handy, save it somewhere, and you can just use it, install the Docker Compose. Okay, so let me just log into my Docker server. Okay, clear it out. So if I just do Docker Compose, the command is called Docker -compose. Okay, and then if I just give version, it will give me the Docker version, Compose version, which is installed. It is 2.17. It is Docker Compose version is 2.17, which is installed. So after installations, if you just give Docker Compose version, you can do that, right? Okay. So as I said, there are not much theoretically to know. It's just a tool to create multi-container Docker applications, right? In one statement, if you want to say. There are a few commands I'm just going to tell you. Using that command, you can execute it. But to write the YAML file, the instruction file, that's most important to understand. Okay, so I have a project created. So I'll just go through the project and I'll just explain you how you have to write your YAML file, right? So if I just go to this particular Docker Compose part, right? If I just go here, you'll see here. So here they have given one things how you have to write it. The Docker Compose, Docker-compose.yaml. So remember, whenever you write the services, see, whatever the things we are using the Docker file. So what is the Docker file? The Docker file contains the instructions, whatever you need for a container to run, right? And what Docker file, if you build a Docker file, what it will create? It's a question for you guys. If we build a Docker file, what it will create?
Image.
Yes, exactly. So it will create the image. So that image can be used in the Docker Compose. So combinedly, if we can just create a Docker file, and that Docker file we can build within the Docker Compose YAML file also, right? We can build within the Docker file also. So here is given some snippet here, something. So if I just check it here, let's go to the project, whatever I have. See, whenever you write anything, so make sure the file naming convention should be matching, like docker-compose.yml, docker-compose.yml, and this file you can just put it here. I have just given a simple syntax here to write it. I'll show you how it is being written. Here, first of all, you have to mention the version, right? Which version of the Docker Compose you are going to use it. In my case, I'm going to use 3.7. It's not the which version, it is the version of the Docker Compose. Okay, it's the version of the Docker, which versions you are going to use it. And then you have to provide the services. So remember, in Docker, any containers we are going to use normally is to say containers and all. But here, these containers being identified as services, and these services are nothing but the containers. Okay, So in Kubernetes, we are going to learn in a different part, like that's called pod, and the pod contains the container inside it, right? So those pod and services, again, we are going to learn on the Kubernetes part. But here, the services, okay, let me just explain you the services, how it is being written. Let me just maximize a little bit here. So if I see the services here, I have declared 3 services. One is the UI part, another one is DB part, and the other one is the PHP MyAdmin. So what happens here? UI part is nothing but the UI applications, the applications content, the GUI part, and the database part, and the PHP admin is a tool which to manage the database. 3 services, that means 3 containers are going to be created. 3 containers are going to be created here. Let's explain the UI part. If I just maximize here, it's very simple format I have written here. If I just go to this, see, simple ways we can write the things here. If I just check it here, I have given build. So in Docker, we used to use the Docker image build command, right? Docker image build command or Docker build, then tag and then give a name and just create it. But here in the build syntax, in the build command, build part, right? You have to just put the Dockerfile path. In this case, the Dockerfile is available in the same context where the DockerCompose.yaml file available. So you can see here we have this Docker file. We have this Docker file, right? See, we have this Docker file. So what it is going to do here? Build this Docker file. First, it will build the Docker file. And what the Docker file contains? The Docker file contains actually one PHP from PHP. Install this one. So very basic image Docker file, right? What is doing? Just getting the base image PHP 7.2 Apache and then installing MySQL on the PHP image container itself. Okay, so simple things is going to create here. Now ports, see, while we are running the Docker container, we used to publish the port, right? 8080, 8080, right? We used to go. Same thing, I'm going to specify the ports here as well. Here I have given 8080, right? And the volumes, see, the volumes, this particular volume, the path, right, container path is going to be mounted to the host path or to the local directed local path. And here the links are given DB. So why this link is required? I'm going to link this UI part with the database, with the DB service. So my DB service contains the database, and I'm going to UI part is going to be connected with the DB. So this container will automatically get connected with this container by using this link service, by using the links. Okay, and the networks, default networks, that bridge network, we are going to use it. Now let me explain you this DB service. Again, here in this UI service, I showed you how we can use the build option to build your own image and use it, right? And in the next service, here I'm going to use the MySQL 5.7.28 version to create the container. See, now you can see how we can build our image Dockerfile, and then we can see here image in the DB service, we can use it. Similarly, we have to use the ports 3306. 3306 is the default port of MySQL because I'm going to use the MySQL database. Now the environment section, in this environment sections, you have to provide the environment variables which are going to be used to the inside the container. So the MySQL underscore database, these are the names, environment variables for MySQL. MySQL database, MySQL underscore user, MySQL underscore password files. Okay. Here I have given the plain text here, MyDB, the database name, and user I have given Ranjit. And here I have given MySQL password file, I have given as Ranjit secrets. Sorry, run /secrets /db underscore password. So these password files, either you can give, if I don't give this particular thing, okay, if I don't give this particular thing, instead what I can give, I have to give MySQL underscore password. Colon, then give the required password. Suppose I give one. So here what happens here? This particular password is going to be used in the database side, right? But it is totally visible to us, right? Anyone can read this password. In order to hide this one, we are going to use the secrets, okay? We are going to use the secrets. That is what this MySQL password file it contains. And it contains the DB password. It contains the DB password. Okay, so here we have to, if you don't give the file, you have to give MySQL underscore DB underscore password. That you have to provide the password name, right? So here I have just created, here you can see run secrets and DB password. That means this particular, whenever the container will get created, the password file will be stored here. I'll show you once we get created, right? I'll show you. The password will be stored under this container path. And here are the secrets, and the secret name was, this is DB underscore password, and the same thing will be like here. And this is the DB root password, okay? Root password means database root password to use it, right? So initial login to the database, it will be used the root password. Here the volumes been created. I've created one persistent volume, and this particular dump directory, if you see here, two volumes been created. One thing is I'm going to mount this particular container path to the dump directory. So I have this dump directory. See, I have this dump directory where the database dump is kept here. The database dump is kept, right? If I just see here, this database minddb.sql. Similarly, this volume, if you see here, right? This is this particular for UI part, this HTML folder, this path is being mapped, mounted to this particular path where it is kept, this www, right? What this www content? It contains one index.php file. It contains one index.php file. So when the volume is created, automatically this links, this map will be added to this particular path, so that the file whatever in dump folder available, right, in the dump, it will be added to this particular container entry point, so that what will happen, that will automatically get executed. So let me show you what this particular dump file contains. It contains nothing but the simple SQL statements. SQL statement. It's just creating a table called portion and then adding some names here. Okay, adding and insert some data, inserting some data here. It's very simple SQL statement. One is creating the table and inserting few data into it. And similarly, the index.php also contains the UI part, right? HTML, that UI part. So we'll see how it looks like. Good. So now you understood, guys, here the volumes part also, and this is the persistent volume will be created. This MySQL folder path is going to add it into persistent volume, right? Now, networks, default network I'm going to use. Similarly, I have one more service called my PHP MyAdmin. Here also VG, same image, and we use links to link the database, right? And port are given 82 different port and 80, right? Because this PHP MyAdmin also default port is 80. I'm just mapping to 82. Similarly, the passwords, it is required, this UI PHP MyAdmin is required this password to connect to the database. So same secret passwords being given it here. Now, so once you create this secret password, you need to define this particular things into this secret path. So in this secret, we have given this DB password, which is nothing but in the containers path we are going to store it. This secret DB password. So these secrets, whatever is given here and here, that has to be declared in these particular secret sections. And the file, as I'm going to use the file here, right? So the file name you have to specify. The file is db_password.txt. So in this particular context, I have two password files present here, db_password_txt and root password. So this password file contains the password, right? You can see it here. So same thing I have been written. Again, the volumes, as it is creating the persistent volume in this section, right? Persistent volume. Here we have to going to create the volume called persistent. Simple, guys. Let's first execute this one and then we will explain more and start working on this. Okay. Now I have created all the required details. Now let's go ahead, and here in the GitHub page this particular project is available. If you want, you can just go ahead and grab it and do the practice. Okay, let me just go through that. Here it is. Okay, Docker PHP Apache MySQL. Here is the project, DockerCompose.yaml. Okay, but here it is. See, here in this here I've just used MySQL password plain text file. Okay, this is not contains the secrets here. Okay, so I'll upload the secret parts. Again, the secret part is also there. If I just go to here, I had created recently one more project, WordPress MySQL DockerCompose, right? Here you can just go through the same things being written. Instead of the UI, we have this. If I just go to the DockerCompose, right, the same thing UI part is there. Okay. Same thing there, and it contains the password files. Okay, now let me just use this one to, okay, what we can do, guys, let me just first upload this part. I'll upload it later and give to you. Okay? So let me go and get this particular project. Let's go to here. Let me clone this project here. Go to the server. Let me first delete whatever unwanted containers are there, which is no more required, right? Container ls-k. So there are three still running. So let me delete all these three, right? rm-f. Then what I can do? Good. So do practice all this time so that these commands easily can be remembered and you can get it immediately whenever you start working, right? So I can just use docker container -aq suppose. So forcefully deleted all these three containers. Similarly, let me delete images if I have any images available. rm. So you can use docker image ls7 not is sufficient. Yeah, good. All images has now been deleted. Let me check if anything available here. Nothing there. No images there. So I just use this docker images, or you can use docker image ls. This is the newer versions of command line. This is the old one. Fine. So both are working. Good. So now what I can do here in this particular folder, right? Let's clone the things, right? I can use git clone, right? Done. Done. Go to the, So here I have the DockerCompose.yaml file, and the same thing, whatever is DockerCompose.yaml file. Okay, now how to execute this one? We have this DockerCompose file, and this particular path, I have the Docker file which is going to be built, and we have the DOM folder, and we have the ww folder for the UI part and the DOM. Let me execute this. One second, please. Okay, let me execute this one. To execute, let me show you there are few commands, not much, there are very few commands which you need to remember. Simple, the command is called Docker Compose op. That's all. Docker Compose op. So what this Docker Compose op will do? It will execute this Docker Compose.yaml file, and the services whatever they are declared in that compose YAML file, it will start. It will start the services. Okay. So two ways you can use Docker Compose op. If you see use, then it will just start all the services and it will attach to the terminal. Okay. Let me show you in the both ways, and you can use -d options and run in a detached mode. Okay. What you can do? Docker Compose op. Docker Compose op. Okay. Now hit enter. See what is doing? It's pulling all the images, PHP myadmin, DB part. Okay. So it's just downloading all the things, images, whatever is required, and then it will start creating the container. Just hold on and wait for a few seconds. All the services will get updated, created. Okay. So it's now, see, and it's building the UI part, right? It's building the UI part. So it is first PHP downloading and it's building it. Okay. See, it's created. Wait for a few seconds. Good. Everything has now been created. Everything has now been created, but it is attached to this terminal. It is attached to the terminal. Let me just log into another terminal. Okay. And let me connect to the server. Good. So if I just do Docker, right, container ls, will have 3 containers running now. See, we have this PHP myadmin, Docker PHP, this particular name, and this Docker PHP MySQL DB. All these are up and running. So our container are up and running, right? So these are the ports which are being forwarded, right? So if I just connect to this particular path, let me just go. So you can see here the logs are still attached and it's working, right? Now how I'll connect this one, as we have 3 containers still running, right? We have 3 containers are running. So similar ways, if I just go here and use docker.ranjitswine.com, and no required for the port. So the default port, if I give 80, no need to give if default is 80, right? So hit enter. See what is this, guys, right? See what happened here. I simply put it, hi, I'm Ranjit here, and this is the Docker Compose class, and these the data which are available on this mydb.sql, right? Ranjit, Kumar, Vahit, and Karthik, right? Same thing has been inserted into the database. Now my UI part, I am able to connect to the database. So what happened here? if you see this particular UI part is connected to the DB container. The UI container is now connected to the DB container because the UI container links whatever we have given is working perfectly. That's why we are able to see the data here, right? We can able to see the data here. Now, if you want to modify this, what we can do, right? Similarly, what we can do here, we can just go to the, where you have to go, just go to the Docker, the folder where we have, and in this DOM folder, okay, in the DOM folder, right? So let's go to the cd DOM folder here, and in this folder we have this minddb.sql, right? Just open this one, and here let's delete it. Okay, suppose I gave something like this, right? Print number. So let's check here. Let's save this one. Okay, I just added this here. Okay, now do you think, guys, whatever changes I did it, will it reflect here also if I refresh this page? It will not reflect. Why? Normally what happens if you do any changes in our Docker classes, last classes, right? In volume path, if you do any changes, it will automatically gets reflect to the container side as well, right? But here in this case, let me refresh it. It's not reflecting here, right? The data is not being changed. Why? It's because whatever the things we have explained, we have put it here. What is does this DOM folder, right? In the volume sections, in DOM folder has been copied into this entry point Docker's daemon directory. So what this directory initialization directory does, whenever the container gets created, it will automatically, this directory will get initialized, means it will be executed when the container gets created. That time whatever data will be inside this directory, it will get executed. So the data was the DOM file, this .sql file, and the SQL file will get executed. Then the data will get inserted, or table will get created, and the data will get inserted. As we have later point, we did changes to the DOM folder, but this entry point will only be executed during the container creations. Okay, that's why the data is not getting changed here. Okay, to do that, what we can do, let's stop the containers, right? So for that, what we can use, see, there are few commands, as I said, we can use DockerCompose off, and we can use DockerCompose down. So when you use DockerCompose down, what it will do, it will stop the services, the containers, and then delete them out everything, right? So let me do that. If you want to only stop it, then you can use DockerCompose stop. DockerCompose stop. Hit enter. Okay. So make sure you are in that folder where the DockerCompose YAML file is available. Okay. Otherwise, it will not work. So it says no configurations file provided, right? So what I can do, I can just go to the directory and then DockerCompose stop. See what it does? Stopping. So our container, if I just check Docker container, ls, no more container running, right? If I do a, all are exited, stopped, right? If you want to start it, so what you can do, again, if I just go and refresh it here, see, page is not reachable, container is not reachable, right? Now let me start it. See, containers are now started. Containers are now started, right? So let's go here and refresh this page. See, but this data is still there, not changed. Now, I used stop and start to show you how to stop the entire container. So, if you use only Docker stop only one by one container, right? But in DockerCompose, you have to use only one command and entire services will get stopped based on the configurations file, right? Now, if you want to stop and delete, you can just go here, Docker Compose down. That's all, Docker Compose down. See, first it is stopping and then removing. Stop, stopping, then remove. So all are now removed. All are now removed, right? If I just check the containers, Docker container, Docker container, then let's see, nothing is there, right? Now, I have done some changes to the DOM file, right? I have done some changes into the DOM file. So I added few different names here, right? So if I just go here and execute Docker hyphen compose up, but this time with up I'm going to pass in detached mode hyphen D. See what happens? It's just creating the services and creating everything and then it started. So it's not now attached to it, simply given the information. But without option D, it was attaching and giving all the details, all the logs details. But in this case, it is giving everything in the back end, not giving in the front end, right? In the foreground, everything is running in the background. Now, if I just go ahead and refresh this page, very good questions will come now. Why it is not reflecting? Though we recreated and added into, why it is not reflecting? Why it is not reflecting here? Can anybody tell, guys? It's very good real-time questions and real-time work also we are going to do it. Why it is not reflecting? Let's check this particular. The database is not getting changed. So we change to the DOM file, DOM folder, but and added into this, and when the container created, it not reflected. It's because of this persistent volume. Because when we first created, all the data has been persisted under this persistent volume, and this MySQL folder has been stored here, has been preserved, right? The previous data was preserved, and when the container gets created, the data are automatically get linked with this MySQL folder. So the data we are getting. So let's check it out. If I just do, right, let me first down it again. Docker compose down. So if you do Docker volume ls, check the volumes, right? Ls. See, we have this persistent volume is there. We have this persistent volume created by the DockerCompose. And though we removed the services and everything has now been removed, right? The container has been deleted, everything, but the volume is still there. The volume is still there. Because of this, the data are not reflecting. Let me delete this volume, Docker, and that's why the data persistence is most important, because sometimes you delete it and something, you can still copy, you can still get a backup of this volume and keep you stored all your required and informations or sensitive informations or important informations, right? You can save it. Now for the demo, let me delete it and show you with how it is getting reflected, right? So we can just use Docker volume rm, right, and the volume name. So the volume is now deleted. If I do ls, see, we don't have the persistent volume available. Now, if I just do Docker compose op now, right? Op, let's see. So once it is created, if I just go ahead, see, all it's very quick, right? Within few seconds of things will get created. Now if I just go and refresh this page, see, it's reflected, right? It's reflected. So this is one of the ways you can do the project in the real time. So there will be another project which we are going to do it in the Jenkins itself. That project will be our Java project, and the Java things which we are going to deploy into the directly into the through Jenkins, will deploy through the Docker containers. Okay, so whatever things we have learned so far, guys, with Docker and Docker Compose, do practice and be ready for the project to work. And also we already have done lots of things in our Jenkins, right? So in this project, I'm going to show you the complete Jenkins setup with the Docker, so that we'll build our project and containerize and Dockerize the applications, deploy the applications into the Docker container. Okay, so for you, the task is just do practice whatever I've covered so far, and the project I'm going to do once you're familiar with the Docker things. Okay, so the project will be done maybe shortly, very shortly. Whatever project we have, I'm going to create a Java a project to build completely from the scratch and then do the continuous deployment. And in our next class, we are going to learn Kubernetes, right? So whatever thing we worked with the containerizations, the single containers, standalone containers, or multi containers using DockerCompose, right, in a single host. But Kubernetes, we are going to learn to orchestrate the multi containers and run them in the multiple nodes, multiple hosts. How easily we can manage them. Okay, that's all, guys, for today's class, and we can meet off next weekend with Kubernetes classes. Okay, do you have any doubt, guys? So if you just see this index.php file, right, this PHP file, in this PHP file we have just written, I have just written here the some statement here, which is nothing but to connect the database from the UI, right? Connect to the database and then fetch the results. What it does, so here the simple, here what is this? This is a very simple HTML or PHP file and having the HTML inside it, right? HTML and PHP server side programming also. So here I am just using under this PHP, I have used DB. What is this DB, guys? See, for the first is host name. The host name is either the MySQL server, right? Database server, you have to place it here. Our database server is DB. So what is this DB, guys? Where I got this?
We mentioned in the nice
Exactly. This is the service. This is the DB service that I have mentioned it here at the host. That's the container, right? And this user Ranjit and password also Ranjit. And my DB, you can see here the database created, my SQL database is my DB, right? The same thing is being given in the index.php file. where I'm just connecting to the MySQL and just executing a small statement here, select star from person. So it is just giving select star from person, and here I've given some HTML combiningly to display the PHP things, to display the data, whatever being fetched from the database, right? That is why it is getting displayed over here. That is the PHP application. Same thing is if you're good with the Java applications, if you're working in a company, in your company, right? So what you can do, you can also use the Java things to deploy it using the connect. So that is why I have kept the project, the Java project, in our next next project, whatever we're going to do with combining with the Jenkins, right? We in between, once we finish this Kubernetes class, or in between that, will do this complete project. Okay. So is it clear, Ibrahim, why you need this PHP?
Yes.
Any other doubt or anything, guys? Ask questions, and if you have any small doubt also. Okay, I think there are no more doubts. So thank you, guys. Well, let me stop recording.